We do not inherit the earth from our ancestors, but we borrow it from our children, is one of the famous quotes of Native America. Our planet is in jeopardy with escalating adverse effects of climate change, global pandemics, environmental pollution, deforestation, and the list goes on. Environmental technology is emerging as one of the effective solutions in addressing all these challenges and making the earth more comfortable and sustainable place for living while ensuring the ecological health. Good morning, ladies and gentlemen. It is with great honor and pleasure we welcome you all to the third Undergraduate Research Symposium on Agricultural Engineering and Environmental Technology. This year's conference is conducted with a core theme of Industry 4.0 and Sustainability towards Innovation-Empowered Nation. We had our first session yesterday and it really went well with your active participation. While today's session is especially emphasizing on emerging trends in environmental technologies. To begin with, it brings me a great pleasure to welcome all the dignitaries to the second session of URSAE 2022. Today's event is privileged to be graced by the presence of our keynote speaker, senior professors, academic staff members, researchers who are going to present their valuable research findings today.
Pavalana silaka dakune Niruvan pirikala terane Panuvan orandunu porane Sarasaviyai me ruhune Sarasaviyai me ruhune Vidya Shilpa Kala Danharavat Labamin Ganamana Karamin Panavat Desabasarasa Surakina Odatedavat Minisun Vimlo Pasasana Gunavat Pavalana Silaka Dakune Niruvan Pirikala Terane Panuvan orandunu porane Sarasaviyai me ruhune Sarasaviyai me ruhune Yuktiya shaktiya bhavaniti sihikar Dagut kulamala patumata vinahara Namaraka parasindu rohana puravara Hiru sandu vemulak sarasavi nilambara Pavalana silaka dakune Niruvan pirikala terane Panuvan orandunu porane Sarasaviyai me ruhune Sarasaviyai me ruhune
URSAE 2022 has been honored to witness the presence of eminent researchers and professionals across the world. Ladies and gentlemen, it is our prime duty to welcome you all to this conference wholeheartedly. On that note, I cordially invite Dr. B.M.S. Jinendra, Coordinator, URSAE 2022, to deliver the welcoming address. Sir, over to you.
Very good morning, ladies and gentlemen. Professor Alice Lechner, a keynote speaker today. University of Monash, Indonesia, Senior Professor C.M. Navaratna, our chairperson today technical session, all head of departments, senior professors, colleagues, all the undergraduate presenters today, and ladies and gentlemen. I'm pleased to welcome you all to the second day session of Undergraduate Symposium 2022. So today we have with us Professor Alex Lechner, Professor Urban Design, Head Research Committee of Monash University, Indonesia, an eminent researcher, landscape ecologist, environmental scientist. Dear sir, I'm privileged to warmly welcome you to today technical session. So I'm sure that your keynote speech will definitely help us to our audience to understand social and environmental challenges and how modern tools will help to mitigate the anthropogenic burden to our environment. So, dear sir, you are warmly welcome to URSAE 2022. And Senior Professor C.M. Navaratna, our chairperson of the technical session second day today. So, madam, you are the driving force today to encourage our student and our young spirit with your experience. So, you are warmly welcome to the session. Professor G.Y. Jayasinghe, Senior Professor, Head of Departments, Agric Engineering, and all the head of the departments, professors, senior lecturers, and young staff members. Besides all other official commitment you have, you are joined with us to encourage our presenters. So, your presence here is greatly appreciated, and you are warmly welcome to the today's session. So our most valuable undergraduate presenters today and the second day of URSAE 2022. So congratulations for your achievement. And today we have 17 undergraduate presenters presenting your valuable research finding. So you are warmly welcome to your today's session. Ladies and gentlemen, so we have started our URSAE 2022, our symposium yesterday with the inauguration session yesterday, and it was very successful with eminent keynote speaker, our keynote speaker yesterday, Professor Hemantha Jayasuriya, and presented 17 undergraduate their work yesterday. So yesterday we talked about our main theme, which is Industry 4.0, sustainability towards innovation empowered nation. So today our theme is emerging trend in environmental technology. So let me say a few words about this theme as well. So yesterday we talked about the industrial revolution and its different phases clearly visible to us. So the first was mechanization. The second phase, that 2.0, industry 1.0 is mechanization. Second was electrification. The third was the electronic age, started in 1950, and then digitalization that was begun around 1990. So actually the environmental concern of people popping up time to time, actually just after the Second World War once, and then this more prominently visible during this initiation of this digital age that was begun 1990. So this was actually with the establishment of this WWW, that World Wide Web. So it was introduced by a British scientist, that Berners-Lee, in 1989. So with that initiation, now all over the world, especially in the US and Europe, that massive servers, because it needed the communication power, networking facility. So all over the in this US and Europe, that began to operate massive servers. So then huge ventilation equipment, and also it started generating e-waste. So due to this reason, so environmentally concerned people, scientists and technologists were concerned about the environment. So therefore, and that era, more emphasis on environmental aspect was initiated, and that was first that the EPA, the Environmental Protection Agency in US, started establishing ranking system. So about energy efficient technologies. So that where we had this Energy Star rating. Now you have your computer a sleep mode power supply option. So that was one of the militants that initiated to mitigate this environmental impact of this new technology development. So that therefore this kind of technology, then this is the time frame that around 1992 up to 1995, the green technology concept was started, initiated, and more prominently visible. So that in green technology, thanks to these new discoveries, so time to time initiated different technologies. And now, for instance, that the environmental concern are emphasis time to time elaborated and emphasis more prominently visible. So, for instance, that we had great hope for providing energy to world by using this nuclear technology. And at the beginning of 21st century, so we had great hope because it is with very high density energy and very clean as far as we can maintain these nuclear power plants. But soon after this 2011, the Fukushima blast, so you all know that. So world opened their eye about their the ongoing nuclear power plant projects. So therefore, we can see clearly visible that the declining of several nations for their the initiation of nuclear power plant project. So therefore, these type of challenges. So therefore, the technologies and we are concerning, instead of generating huge amount of energy and wasting them, we are trying to use energy efficient equipment, like the increase in the energy gain, that end-use efficiency gain, where that we have invented these LED bulbs. So you know that the simple LED bulb, yesterday also we talk about that. So a lot of huge amount of millions of barrels of fossil fuel burning and protect the environment. So therefore we need such type of discovery. And when we think about modern trend, so we have this the new technology, more environmental sustainable and environmental friendly technology like biomimicry. So mimicking the observing the nature phenomena and introducing this into new technologies. And then biotechnology and nanotechnology, and those are emerging. And on also digital platforms and digital, so such as remote sensing, GIS, and has much to do protecting our environment. So and this, therefore, it is one of our prime duty to work towards the environmental sustainability. So we need new strategies and ways and means to ensure surveillance of human race in the planet for its sustainability in future. So therefore, as a coordinator of URSAE 2022, I highly encourage our young presenters today to consider the emerging trend in environmental technology and do your level best for the society. So hope this second day of URSAE 2022 will help you in this regard a lot. So enjoy your second day, do your level best in presenting your work and discussing the emerging trend in the environmental technology. Have a nice day and have a fruitful discussion during your presentation time. And thank you very much. And over to you, Kirtina.
Thank you very much, sir, for providing a clear insight of today's event and explaining on the essence of sustainability, green technology, and new emerging environmental technologies. And there's a kind request to all the guests and the students to turn on your videos, to take few screenshots to keep this moment that lasts forever and to cherish. Kindly turn on your videos to take few screenshots.
I am sorry, Kirtana, host doesn't allow me to switch on my camera. It says unable to start video. You can't start your video because the host has stopped.
Sure, Madam Anushka. Thank you all.
Yes. Okay, now right.
With great pleasure and respect, I cordially
you.
invite Dr. BMS Jinendra, Coordinator URSAE 2022, to introduce the chairperson of today's scientific session.
Thank you very much, Kirtina. Let me introduce Senior Professor Champa Navaratna, Chairperson Technical Session today. Senior Professor C.M. Navaratna acquired her BSc Agriculture from the Faculty of Agriculture, University of Ruhuna, and obtained her Master in Computing in the University of Wales, UK, and possessed a PhD in Agricultural Engineering. And she is currently working as a Senior Professor in the Department of Agriculture Engineering, Faculty of Agriculture, University of Ruhuna. Her major field of interest were integrated water resource management, IWRM, hydrology, and climatology. And with decades of experience in her discipline, she is now contributing to the climate change, carbon balancing, environmental footprints, disaster resilience building, and she was able to publish more than 100 research articles in these fields. So she is the coordinator of EU-funded Erasmus CBHE project called Building Resilience in Tropical Like Local Climates, and where the University of Ruhuna is leading. So further, she is the university coordinator for two other Erasmus projects called BEC and SECRA. So she engages with the outreach activities other than her university commitments and network of women's water professionals, Sri Lanka Water Partnership and Cabinet Lanka. She organized a number of awareness programs and served as a resource person in many capacity building workshops within the country as well as overseas. So with that very brief note of contribution and for the science and technology, I cordially invite Senior Professor C.M. Navaratna to chair the technical session today. So over to you, madam.
Thank you very much, Dr. Jinendra, for your introduction of myself. Now, actually, good morning to you all. Good morning to you all, ladies and gentlemen, and especially Dr. My first duty, welcome you all to the session 2, Emerging Trends in Environmental Technologies. Under this, my first duty is to Alex Lechner, Professor Alex Lechner. Actually, I am honored to introduce you here. Dr. Alex Lechner is a landscape on the Masters of Urban Design. He has over a decade of international experience conducting research and teaching on the application of interdisciplinary approaches to urban sustainability, environmental science, and geospatial analysis. He has held a variety of roles in Australia at the University of Queensland and University of Tasmania, and in Malaysia at the University of Nottingham, Malaysia, and most recently at the University of Lincoln, UK. Originally from Australia, Dr. Alex has a BSc in Ecology from the University of Queensland and MAP Science specializing in the geospatial science and a PhD in Landscape Ecology from RMIT University, Australia. Dr. Alex Lechner has over 100 academic publications in top-tier journals such as Conservation Biology, Remote Sensing of Environment, Nature Ecology and Evolution, and Nature Sustainability, and Landscape Ecology. His research focuses on developing methods to support sustainable planning and participatory decision making through the development of novel spatial approaches, including ecosystem services modeling, wildlife connectivity analysis, remote sensing, and participatory web-based GIS mapping. He has undertaken research across the world from Oceania to Southeast Asia and Europe and has a successful track record of applying landscape ecology methods to a broad range of cross-cutting areas, including threats to environment from infrastructure development and resource extraction, in particularly urbanization, impacts on landscape fragmentation in wildlife, and supporting socio-economical changes with interdisciplinary approaches to modeling and collaborating across environmental domains and disciplines. Uh, Further, he contributed to equivalent of $1 million and 19 grants awarded, including competitive research funding, competitive university research funding, international government grants, and industry funding. Apart from that, he is a teacher for master's degree program in urban design. He conduct courses city ecology as well as ecology and health. Further, he is a fellow of Higher Education Academy in UK, and he has successfully graduated 2 PhDs, 1 MPhil, and 5 MRS students, and currently supervises for 4 PhDs, 6 masters, and research MRS, and 2 MPhil students. He is an active member of several journal editorial boards, as well as he is an active member of the conference organizing committees. He has numerous membership in well-known societies in several countries. Actually, we can say in the world. So actually, we are fortunate to have Dr. Alex as a keynote speaker here. We are very fortunate. So I cordially welcome you to deliver your speech now. Thank you very much.
Thank you very much, Professor Navaratne. I hope I've got that right. It's a real honor to be asked to make a presentation to URSAE. It's very exciting. Also, one of the reasons why I was particularly excited about making the presentation is that I was the former co-supervisor of one of your staff, Prof. David Minnie. So it's really lovely to be giving back again. And so I'll start sharing my screen, if that's okay. Let's hope this works. Okay, fantastic. So I think in the next 20 or so minutes, what I'm going to do is present on remote sensing applications for ecosystems, biodiversity, and forest mapping. And I think it's a really nice theme, a topic area that really represents one of the huge and really important emerging trends in environmental technologies. And I hope all the students will gain something from this presentation, get an understanding about some of the future trends in this area. And I think one of the trends that's really important is to look at, and I heard the previous speakers talk about this, is the level of technologicalization of disciplines. And I think the remote sensing applications really represents one of these fields where we're seeing interdisciplinary, transdisciplinary approaches, bringing in engineering, bringing in agriculture, bringing in ecology, bringing in remote sensing methods, bringing in computer programming, for example. All these approaches are really coming together to do some really incredible stuff. And especially within this field, especially for all you undergraduates looking towards the future, what should you learn? The skills and the ability to work with this kind of technology is one area, really pushing the field in agriculture, in forestry, in conservation, and so forth. So the future leaders in areas of such as remote sensing, for example, will be the people who have these technical skills, who can program, for example, who can use machine learning methods and so forth. So I will keep moving on. So hopefully, yes, everyone can see the screen and the title. So my presentation today is largely based on this review paper, Applications in Remote Sensing to Forest Ecology and Management. So if you want to, dive a bit more deeper on this topic area, feel free to download this paper now and take a look. It's open access, so in that way, it shouldn't be a problem to access. So first, remote sensing. It's one of these emerging technologies, one of the key emerging technologies that is really influencing, people in environmental science, people in agriculture all across the world. We know, hopefully you have a bit of an understanding, but you'll know about this idea of precision agriculture, for example, which uses GIS, but underpinning many precision agricultural methods, for example, is the application of remote sensing data. So in this presentation, I'm going to start off by giving you sort of an overview of why is remote sensing such a critical tool across the world for many different fields. I'll then go take a step back, perhaps, and because I'm guessing not everyone has a background in remote sensing, and just give everyone a flavour of where remote sensing is at in 2020, in the 2020s. And then at the end, I'll go a bit more high level for those who have interests, talking about where's the future of this field that is remote sensing, and especially for undergraduates thinking about where they'd like to go, the skills they'd like to develop. This should give you a bit of an idea about, what the 2020s and the 2030s will look like in terms of remote sensing. So first, there are 6 key reasons for the ubiquity of remote sensing. This is what we wrote in our paper. And the first is that remote sensing provides a synoptic view. So remote sensing is incredible in that what it provides is a view of every visible feature, capturing its location and its relative location to other images, other features in the landscape. It provides wall-to-wall mapping and monitoring of important ecological variables such as land cover change. We can map soil condition. There's all sorts of important variables that can be mapped. But the key thing is it's mapped for the whole landscape which we're focused on, which is very different to many existing approaches where remote sensing are being applied now, which may have, for example, involved field data or may have involved sort of monitoring stations at point data. So there's a big difference in terms of a remote sensing perspective to understanding locations. Of course, what would be really fantastic is combining the field and the point data with the remote sensing data, these data fusion products. So number 2, remote sense data available everywhere and often at a range of spatial and temporal scales. So we have global coverage with many, many different remote sensing sensors, from sensors where we have the pixel. I hope you know what a pixel is in a camera, where the pixel size can range from anywhere to centimeter precision all the way to 500 meter or 1 kilometer precision. So we can have, and in terms of the temporal scales, we have satellites or satellite systems gathering daily data on every location in the world now. So it's really incredible in terms of those spatial and temporal scales. One key element about temporal scale is the ability to go back in time. So we can use historical data. We have some satellites like Landsat, for example, you may have heard of, which has data dating all the way back to the 1970s. The good data is only from the 1980s. So even if you don't know, you didn't even have an inkling, you perhaps weren't even alive at that time, you can actually look at the historical data to see what a region, a location was like in the past, which is incredibly powerful and incredibly important. Of course, something you can't do if you're gathering new field data. So number 3, remote sensed imagery often has a high degree of homogeneity. So data acquired under relatively fixed conditions, and the data is captured, is related to the way radiation interacts with the environment. Unlike field data, for example, which may be dependent on the person undertaking the survey at the time, that they could be different weather conditions, lighting conditions, all sorts of things, which may mean the way the data is captured will differ, and this type of issue around the data capturing is not as great an issue for remote sensing data, and that's where I say there's a high degree of homogeneity. So we can even look back in time 20 years using remote sensing data and compare to current remote sensing data without massive issues, unlike if we were to look at field data, for example. Number 4, so digital images are easy to integrate with other spatial data sets in GIS systems. So hopefully learning GIS is one of the skills that you have. You know, these days, understanding and using GIS is like almost using Word this way, or Excel. So that, you know, this is part of your toolbox. And of course, digital data from remote sensing is very easy to integrate through a GIS system, which allows us to do all sorts of queries, analyses, visualizations, really powerful communication and analytical tool. Number 5, so remote sensing is an inexpensive way to acquire data at the per unit area of study. So this is especially where labour costs are high. Remote sensing is particularly excellent. Remote sensing data can access areas that are often difficult to access physically, for example. So, and furthermore, it's very inexpensive in that there's already a range of remote sensing data sources that are freely available that can be utilised for anywhere on the Earth. And finally, number 6, which is part of one of these future trends, is that there's this increasing trend to the provision of data products. So you can now, environmental scientists, even if you're not a remote sensing expert, you can now access high quality data products from remote sensing, web-based mapping tools, for example. So rather than only having the option of downloading the raw data, now we're at a stage where you could download the final data products quite easily from remote sensing, meaning that level of expertise, remote sensing expertise, is not required. So these are the 6 key reasons. I'm sure there are more, but these are I feel these or variation of these reasons are really driving the ubiquity of remote sensing as a technology to support environmental science, to support agriculture, and so on. So let me just take a bit of a step back now and just consider, when I mean remote sensing, what do I actually mean? For those people who haven't taken many classes or are perhaps a little unfamiliar. So when we think about remote sensing, we think about the platforms and we think about the sensors. So the platforms are, the things that fly in the air remotely. It can be even handheld. A phone can be considered a platform, and your camera in your phone can be considered the sensor. So we have spaceborne, which we call Earth observation platforms, and then we have airborne platforms, and finally ground-based platforms. Types of platforms that we commonly get access to are most likely spaceborne platforms. This is where we get all this freely available like Landsat or Sentinel data, for example, while for ground-based, we can really see this transformation in terms of remote sensing technologies, in terms of UAVs and even low-cost UAVs. So a classic Digi UAV, for example, can really do some fantastic remote sensing, it's used across the world. While we also have airborne, which is a little rarer because of just the costs. This is where you pay for a plane with a sensor on board. Sometimes it's permanent, sometimes it's not, to actually fly and remotely sense a particular area. In terms of the sensors, the classic ones we have are what we call the passive sensors. So this is just like your phone camera, where the light that's reflected from the sun back into the sensor captures the data. It captures the data at a variety of wavelengths. You probably, hopefully you remember this from physics. So there's a range of different wavelengths, which then becomes our sort of data, which we can then apply algorithms and convert that into a land cover map, can measure different environmental metrics or so forth. We then have our active sensors. So LiDAR is the classic one. It's where lasers are shot off from our sensor. These lasers are shot from the sensor, they reflect back, and depending on what happens between the shooting and the reflecting and the capturing, we can derive a variety of information. Particularly important for LiDAR is the ability to capture like height and structural, so the vertical data. And the final one, classic sensor, is that of synthetic aperture radar, which is also a active sensor. And the fantastic thing about both these active sensors is that they, can shoot through clouds. So clouds are a particular problem for people like you guys and myself. I'm in Indonesia, in Jakarta, where we have lots of cloudy tropical days full of rain, which is a problem for remote sensing. So in terms of remote sensing data, this diagram here basically compares different types of active sensors. So at the top, we have what's called multispectral data, and we have hyperspectral data. The key take home from this is that each different band, which is based on a different wavelength. So we have the visible wavelengths, we have blue, we have green, we have red, we have the non-visible wavelengths like near infrared and so on. I'm sure you're aware of that. But each of these bands represent a different kind of data that's captured by different sensors, which are then used within our classification algorithm, which is much like a more complex version of sort of multivariate statistics in a way. But so the common sensors look like Landsat and Sentinel, but we have more complex sensors, which are hyperspectral sensors, which have multiple thousands of different bands, which each can be processed and understood. So in terms of what do we do with our remote sensing? So there's a range of different variables that we can derive. So this diagram here just represents some of the key variables, especially for forests, but also very relevant to agricultural environments, and the key combinations of sensors and platforms. So we have different domains, from land use to land cover, general kind of cover. So land use and land cover is categorical, while cover is represented by continuous variables such as greenness, coarse woody debris, tree density. We can map vegetation structure, tree height, above ground biomass, crop productivity, for example. We can map vegetation chemistry and moisture, such as foliar chemistry, moisture content. We can also map biodiversity, individual species, for example. And we can map disturbance, especially using our temporal data sets, where we look at the past and the future and see which areas have changed, and we can map properties of our soil. So I won't go through the whole table, but you can see that some sensors and some combination of sensors are good for some things and not other things. The key take-home message is that commonly the workhorse in remote sensing is the application of multispectral data. Both are fine resolution spatial data. So that's, you may have heard of WorldView 2, which takes 50 centimeter pixel sizes, or we have our multispectral medium to coarse spatial resolution data, which is our Sentinel, which has 10 meter pixel size, and our Landsat, which has 30 meter pixel size. You'll probably more rarely come across these other forms of sensors. So the key thing is, there's a variety of steps and a variety of experts that have to come to the table to produce, our classified maps or our true color imagery, for example. And there's a variety of steps that need to be taken if we are going to undertake a single mapping event for a single time location versus if we want to look at a time series, for example, if we want to look at patterns of disturbance. And there are different methods if we are depending on some of the atmospheric conditions and the classification methods. So one of the key issues, so you're faced with this choice of all these different platforms, these different sensors. How do you decide which one to use? So there's a range of factors that you'll have to think about in terms of the phenomenon you're trying to map, and they vary in terms of spatial and the temporal scale. So when you're mapping at regional scales, for example, you may use some more of the coarse resolution sensors versus if you're mapping at a local scale and you want to, for example, even capture leaf orientation or tree or vegetation or crop structure, for example. So there'll be a variety of choices and sensors available. The thing is, with remote sensing, there is no single best sensor. Every sensor and platform system is actually a trade-off between the spectral resolution, which I described, hyper versus multispectral, the pixel size, for example, from 0 to 30 meters, and the revisit time. So it's important to realize there's no perfect sensor. Sensors, classic ones such as Landsat 8, so they have a revisit time of around every 14 days. They go around the Earth and take another picture of a certain location. Landsat has a 30-meter resolution, and it has around 12 or so bands. And then we have Sentinel-2, which is another multispectral sensor, which is really popular, which has a resolution of 10 meters and more bands, and also similar revisit times. So you'll have to make lots of choices and understand the different trade-offs between the potential for different sensors. But the fantastic thing is the number of sensors and platforms has just exploded in the past 5 or 10 years. We are doing things now that were not possible 5 or 10 years ago. It's a super fast, exciting, moving area of research and application. So in terms of, I'm wrapping it up now. So in terms of the future, in terms of emerging technologies and approaches, the number, range and performance of platforms are increasing dramatically, so that there are actually probably more platforms and sensors and things out there, then people have had time to really push in terms of generating algorithms for utilizing these sensors for mapping all those different kinds of environmental variables. So super exciting. There's greater diversity of players from government. So it's not just sort of the US, and it's not just Europe, for example, shooting rockets up with satellites now. It's also numerous countries, and it's also private industry as well. Now, previously, when I talk about Landsat, which is the classic satellite, begun in the 80s, one of the first remote sensing satellites. Since then, things have changed dramatically. So now we have satellite constellations rather than single satellites as in the past. We also have UAV remote sensing, and that's having a significant role in providing organizations with remote sensing capabilities, which didn't exist before. UAVs are low cost and technically not super challenging. And we have massive advances, and this is really where I mean that the field has really moved in terms of the skill set required. We're moving beyond clicking and software applications to applying programming methods, and people from computer vision, from IT are moving into the field of remote sensing, applying our machine learning and deep learning algorithms to do remote sensing. And finally, we have applications such as Google Earth Engine, which is, the only one like it so far. But Google Earth Engine basically provides both the algorithms, cloud computing power, which allows you to undertake global scale remote sensing analyses, and also has the data sources as well. So it's a fantastic portal. I urge you, if you're interested in remote sensing, you don't need any money, can just get on Google Earth Engine and do some wonderful remote sensing. So in terms of final words, remote sensing methods are an important part of the solutions to address all these big global challenges, these challenges such as climate change, such as biodiversity, such as food security. Remote sensing is critical for all of these challenges, and is just going to get bigger and bigger. So it has a key role, especially for us in tropical ecosystems. The tropical ecosystems are home to some of the most intact high biodiversity areas. So the monitoring and looking at change, degradation, and so on of these ecosystems present in Sri Lanka, in Indonesia, is a really critical role for remote sensing, which leads to the next part. There's a greater democratization of remote sensing through advances in a whole range of open access data in terms of free remote sensing data, free softwares and platforms such as Google Earth Engine, which means, playing around and using remote sensing data to undertake really high quality analyses is something that's open to everyone now. So I urge you, if you have an interest in this area, take a look at what's happening in this field. I think it's one of the really exciting fields when we think about emerging technologies. So I'll finish up there. Thank you very much. And I'm open to questions.
Thank you very much, Professor Alex, for your insight presentation regarding on remote sensing application for ecosystem biodiversity mapping. Thank you very much. Actually, we got a lot from your presentation. Yeah. Dear audience, are there any clarification from Professor Alex for this presentation? Hello?
And maybe I think we have a question.
Yeah. Hello? audience?
I may have.
Yeah.
Yeah,
let me
actually,
ask
yeah, it is a
something.
great experience. Yeah, Jinendra, yeah.
Yeah, Professor Alex, can you tell me different and new development that modern development of sensors, I mean, with high processing power in applying in remote sensing?
So I think one of the really exciting areas, so it's perhaps not the sensor itself, but more the range of platform is it's called Planet Labs. So everyone can have a look at that. So this is a private company which has shot into space. It's around 300 small miniature sort of, I think they're like 5 kilo sensors. So the normal remote sensing sensors that we probably may have heard of our Landsats, our Sentinels and things like that. They're quite massive, car-sized, I think. But these are miniature 5 kilogram sensors. So what they've done is they've created this constellation of around 300 sensors orbiting the Earth, which then allows us to have unprecedented coverage in terms of, daily remote sensing of any location on the Earth. So I think this is quite an amazing thing. And this is a private company-led initiative, which is very different to, historically, the remote sensing sensors, especially Earth observation sensors, have been built by the government, paid for by the government, and to serve government. So I think that's represents kind of one of the future directions. It's kind of like Elon Musk in a way, whereas he's working in space, there are people working in, for example, remote sensing, where private industry is really getting in on and coming out with really innovative solutions. And you can look at Planet Labs, and that data is available online as well. And I think it's kind of free for if you only use so much.
Thank you very much. So it helped a lot. Thank you.
Yeah. And if students are interested in, feel free to ask, a question, for example, like what should I learn if I want to work in this field?
So that would be, a nice question. Yeah, you are celebrating. How to initiate?
I'll answer my own question. So I think one of
Yes, elaborate how to technology. Yeah.
I have a feeling, I don't know all the students, of course, personally, but I have a feeling they may have a similar background to me. So I started with a passion in ecology, and I did a Bachelor of Science. So I think so if you're in agriculture, or if you're in one of these sort of environmental science type disciplines, or even civil engineering and things like that, the sort of remote sensing and GIS approaches are really an excellent add-on to making you quite unique in terms of your skill sets. Because what we find, I think, a lot, when we learn a bit more, I don't know how to say, like fluffy sciences, when you get to the job market, people are often after real technical skills. And one way that you can make yourself quite different and unique is having these high quality GIS skills. So perhaps they can stay with you and do a master's or something in this area, because I reckon that's one of the areas, because more and more in various fields, we want evidence-based approaches. We want quantitative data to make our decisions from. And as hopefully I demonstrated, remote sensing is one of these technologies. So what I'm saying, to sort of wrap this up, is this idea that, your agricultural degree or environmental degree is a really nice underpinning, and then to learn some technical skills in GIS and remote sensing is really fantastic. One aspect of learning these GIS and these technical skills is I would like to push everyone to do programming if they can, to learn Python, for example, or JavaScript. You know, these are the skills of the future in terms of where more and more people are needing to be able to program. So in my field, we've moved, so I learned how to use GIS software and Click and so on. But in these days, what people are learning is the GIS software plus programming. So it's a really interesting trend. And I'm guessing this trend is in similar other kinds of like engineering fields and so on. So GIS and remote sensing with programming is get as technical as possible is my suggestion.
Well, thank you, Professor Alex. I think that a lot means. Thank you.
Yeah, thank you very much, Dr. Alex, for your, actually, now you have given a very good advice to our students. Yeah, very good, actually, and your very valuable presentation for everything. Thank you very much for presenting you here today, actually in presence of us, and your valuable time you spend for us. Thank you very much for everything. So I think, I don't know whether we can give applause to you because we are online. Okay. So
If I'll just like to say it was an honor to present, and I'm really happy.
Others all camera off and mics off. So thank you very much. We are looking forward your support in future for our faculty. Yeah, we will.
I would love to. I would love to.
Be in contact with you. Yeah, sure.
Yeah.
Thank
Good
you.
luck with the conference.
Madam, Kasu, the bell so Kushan has raised.
Oh.
Contact. Yeah. Kushan, yes. Kushan, any question?
Actually, I wanted to applaud him and for the accepting our invitation actually.
Yeah.
To select. And also I have one single question. So I for my postgraduate degree, I have with the remote sensing, and I did some research related to the resilience and resistance assessment of vegetation that are affected by the hurricanes. So are there any new trends in that field? Like, for example, because we know that forests are some of the vulnerable ecosystem when it comes to the climate change scenario. So are there any new trends in remote sensing?
Thank you for the question, Kushan. And I imagine you probably know the new trends in this area. But what I can say, what we're recognizing all around the world. So if I take a step back, is just the importance of climate change. We're going to see more of these hydrometeorological natural disasters. And we can see massive global investment in this area, for example, with the Green Climate Fund, for example, which is, a multilateral fund spending money, which is part of all the COP27, these agreements that lots of countries have made in terms of helping low and middle income countries like Indonesia, like Sri Lanka, to address in terms of adapt and mitigate to climate change. So what I'm trying to say is the research you're doing, is completely super important. And is one of these trends in terms of the future. We're going to need more and more of that research. So I urge you to just keep doing more of that great research. And I think in terms of research like that, what we're seeing, future directions, like with most of remote sensing, is about bringing in all the different kinds of sensors, expanding on the spatial and temporal resolution you are looking at, for example, using historical data and Google Earth Engine, for example. I'm not sure what your views, for example, what we can do now is we can combine like every single available image for a specific location within a single algorithm. So previously, if we're looking at change, for example, we might go, oh, let's pick 1 year and then pick a previous year in the past. Where we're moving in terms of for understanding change, which is something that's really important when we're looking at climate change, where we're looking at disasters, is now what we can do is actually we have the algorithms and the computing power to just include every single image available, which is hugely exciting. So there's a trend in terms of applications of temporal analyses like Land Trend R, you may have heard of, which is the algorithm that looks at disturbance signatures, for example. I'm not sure what scale you're working at, so of course it'll be vary, but this is definitely one trend, you know, from the investment in your area being really critically important, and also the technology is kind of advancing so quickly in that way. You know, so keep working in this area is my suggestion.
Thank you, Professor.
Okay.
Yeah.
Okay, thank you very much, Professor Alex. So again, we will thank you again.
Thank you
again.
very much.
We will be in touch in future too. Okay,
Thank you.
Thanks. Let's start our technical session now, morning session. The first presentation, a comparison of natural, durable and treated wood field performance under tropical conditions by MMT Madhushani, R.U. Halwathura and G.Y. Jaisingha. Ms. Madhushani. Hello, Praneeth, cannot hear. Anushka? Chinta ehenawada?
The wood can be described as I'm MMT Madhushani and my research topic is a comparison of natural, durable and treated wood field performance under tropical conditions. These are the outlines of my presentation. Introduction. The wood can be described as the core substance of a tree or a shrub's trunk. When we consider the chemical composition, wood is consist of cellulose, hemicellulose and lignin. Among different kind of construction material, wood has been used in large quantities due to its low cost, ready availability and low environmental impact. According to the European standard, natural durability of a wood can be described as the inherent resistance of wood to attack by wood-destroying organisms. Since natural extractives like tannin, oils and resins, wood are naturally protected. But depending on the amount of these natural extractives, the natural durability of a wood can be varied from one type to another. Due to the chemical composition, wood tend to degrade by microorganisms like white and brown rots and termites. Among them, termites are the most destructive pests attacked on the wooden buildings. To overcome the negative points of wood like moisture sensitiveness, low dimensional stability, hardness and wear resistance, we used wood modifications. Modifications can be described in three types. Modifications in the cell wall, impregnation and coating. Thermal and chemical modification are the two types of cell wall modification. My study is focusing on chemical modification. Problem statement. All the four preservatives introduced so far have one or more deficiencies like permanency, toxicity, heat resistance, environmental impact, and cost. So, clear identification of effective and environmental friendly wood preservative is contemporary necessity. These are the objectives of my study: to evaluate the performance of solutions, namely FSWM and FSWOM, and artificial wood preservatives, namely ACQ and boron treatment, by investigating the field performance of treated wood and compare the field performance of treated wood with the natural durable wood. Materials and methodology, solution preparation, Glycidia sapium, Titonia diversifolia, and Micania micrantha is used according to the ratio mentioned here for the preparation of FSWOM solution. By addition to these plant leaf extract, by adding mud from organic fertilized paddy field, FSWM solution was prepared. These are the steps used to prepare FSWM and FSWOM solution. For the application of wood preservatives, dipping method was used and wood samples were dipped in the solution for 24 hours. 5 replicates from each wood type was used. As positive controls, mahogany, teak and jack were used, and as negative controls, Alstonia, rubber and mango were used. After application of wood treatments, wood samples were oven dried at 103 degrees Celsius for 24 hours and then exposed to the field for 3 months. Visual observations were carried out in every 30 days. After 3 months, wood samples were washed out and oven dried at 103 degrees Celsius for 24 hours and measure the final weight in order to calculate the average mass loss percentage. Determination of moisture content according to the standard process. Wood samples were oven dried at 103 degrees Celsius and calculate the moisture content by following equation. Small growth evaluation. Wood samples were exposed to the field for 3 months and visual observations were carried out in every 1 month interval by using the standard evaluation criteria mentioned here. Evaluating the chemical retention. To evaluate the chemical retention, following equation was used, and to evaluate the mass loss percentage by termite attack, wood samples were conditioned at 103 degrees Celsius for 24 hours and weight of the samples were recorded before and after the test. Results and discussion. Analysis of mass loss percentage. When we consider the mass loss percentage in Alstonia, there was no significant difference among all the treatment, but when we consider the rubber and mango, ACQ treated wood shows the lowest mass loss percentage and there was no significant difference between all the treatment among durable wood. In the both of rubber and mango, ACQ treated wood result the lowest mass loss percentage and boron perform less performance than ACQ but higher performance than the natural wood preservative. Similar results were recorded in the previous studies also. This figure shows the termite attack on mango and rubber wood. Small growth analysis. Moisture is a necessary factor for fungal growth. If the moisture content is less than 30%, it will not be a problematic. Previous studies also shows that mango show higher moisture content when compared with the Alstonia, rubber, teak, jack and mahogany. And when we apply boron, it helps to avoid the fungal growth in treated wood. According to previous studies, when we wood preservative content copper, it helps to avoid the mold growth. This graph shows the moisture content in Alstonia, rubber, mango and natural durable wood. Mango shows the higher moisture content among all the samples. Fungal growth in mango wood with the red is shown in this figure. When we consider the chemical retention in both in Alstonia, rubber and mango, FSWM and FSWOM show higher chemical retention. And according to previous studies also, same results for the chemical retention in ACQ was recorded. Conclusion. The lower performance of FSWM and FSWOM solutions were resulted, and it is recommended to take preventive actions to enhance the sealing quality of these natural wood preservatives. Highest performance in prevention of termite attack and mold growth was recorded in ACQ treatment. Boron treated wood were noted lower performance in prevention of termite attack than the ACQ treated wood at the same level as FSWM and FSWM solution. Prevention of mold growth in rubber and mango is higher than the natural wood preservatives but lower than the ACQ. So, the study concluded as ACQ wood preservative is the most effective wood preservative for mango and rubber, and further it enhanced the service life of mango and rubber as natural durable food. These are the references I used in this presentation, and thank you.
Thank you, Ms. Madhushani. Now the floor is open for the discussion. Any questions regarding Ms. Madhushani's presentation?
Good morning, Ms. Madhushani. Is it possible to have a kind of the commercial level application with these findings of your research?
Yes, madam, but we have to, first of that, we have to improve the sealing quality of these natural preservatives, then we can go for a commercial development.
Can you recommend some, which type of things you can recommend?
Yes, madam, first, we can use some oil coating or commercially available coating, but now we are seeking for a natural coating to combine with our preservative, madam.
Yes, I am asking about naturally available thing. Which one is more suitable?
Oil like that one we can use, madam.
Madhushani. So thank you for the interesting presentations. You have used 3 plant materials to produce that natural wood preservative, right?
Yes.
So what is the reason for selecting those 3 plant species particularly? Is there any reason out of literature review how you have selected?
Usually I follow the literature also, and usually in commercial level we don't use for long lasting construction mango rubber due to its moisture content, high moisture content, so it tend to degrade easily. So I choose those 2 for my research. And Astonia, it's a kind of not a hardwood, but it has somewhat natural durability than the rubber and mango. So to compare, for the easiness of compare and find whether it enhance the service life of these rubber and mango, I choose Astonia.
Okay, thank you.
Okay, Ms. Madhushani. I also have a question. Is that are those the only pest and the maybe fungal is not the pest, the things that attack for wood?
Didn't get it, ma'am.
Yeah, only you have to you have here that about only the termite attack you have addressed termite attack and fungal attack. Are there any other pest for wood?
There are, madam, but my study is focusing on mainly termite, madam.
Termite.
Termite and fungal worm.
All other pests can be, they can be attacked anyway. Okay. Okay, thank you very much. Any other questions for Ms. Madhushani?
Yes, madam.
Yeah. Yes, Anupa.
Yeah, I would like to thank you for your nice presentation. So I would like to ask that your the wood samples for 3 months, did you keep it in a same condition, or is that are there any changes in the conditions?
No, sir. In the same location, and my research is continuing for 1 year period to evaluate the tropical conditions all the year round, all the weather conditions, sir.
What kind of place did you put those things? What type of where? I mean, in a room condition or?
Outdoor conditions, sir. Contact with the soil and field.
Okay. Thank you.
Okay, since I think time is up already. So thank you very much, Ms. Madhuchani, for your nice presentation. Let's move to our second presentation, assessment of environmental impacts of MSW disposal options used in LCA methodology, a case study in Mathara municipality. The presenter is HKMG Kalhari, and there are other authors, Jayanta Veeratna and S. Vijayatunga. Ms. Kalhari, the floor is yours.
Ms. Kaina Kalhari. My research topic is assessment of environmental impacts of municipal solid waste disposal options using life cycle assessment methodology. Case study in Mathura municipality. These are the topics that I'm going to cover today's presentation. Just by hearing, we all know the municipal solid waste is a serious problem that Sri Lanka is facing today. Mismanagement of this waste that cause severe damage to environment and human welfare. Mathura is one of the cities that has been in controversy regarding this municipal solid waste problem. The population density in Mathura municipal area is relatively higher in comparison with other Pradesh Sabha divisions. As high population density, urbanization, the municipal solid waste generation rate is high in Mathura municipal area. Increasing quantity of solid waste make pressure on local authorities responsible for collection, disposal, and management of waste. Mathura Municipal Council is the responsible local authority for the management of municipal solid waste. Let's see the problem statement. Decomposition of biodegradable waste under anaerobic condition cause odor problems. It may cause unpleasant experience to surrounding villages. One of the existing method of waste management, which is landfilling, cannot consider environmentally friendly. Not only that, but also now it comes to its maximum storage. So there is necessity for introduce alternative waste management options. The objective of my research is determination the potential environmental impacts associated with Kotawila solid waste management complex using life cycle assessment tool, and also identification of alternative options which reduce the environmental burden. This is the methodology that I followed during my research. My research study area is Kotawila Waste Management Complex. For that, the responsible local authority is Mathura Municipal Council. These are the basic data about Mathura Municipality. It is spread over 12.8 square kilometers. The population is 73,733. Population density 5,760. There are 41 Ramanadari divisions, and Mathura municipality divided into 20 zones for the waste management process. Life cycle assessment start with goal and scope definition. So the goal of this research is identify the environmental impacts associated with the existing waste management practices in Mathura municipal area and find the alternative options for the waste management. For that purpose, the functional unit is 1 ton of municipal solid waste. This is the system boundary.
It covers from waste collection point to their final disposal methods. These are the basic data regarding the municipal solid waste. The average amount of waste collected per day is around 35 tons. This chart shows the waste composition. According to that, the highest amount of waste take place degradable waste. Others are plastic and polythene, textile, glass, paper and cardboard, and also there are hazardous waste. Among that, recently, 4.19% of waste treated by composting process, 8% of waste treated by recycling process, and other amount of percentage of waste goes to landfill as the final disposal method. This diagram shows the current situation of Kottawila Waste Management Complex. In 2009, under the Pilisaru Waste Management Project, this land area was selected as the compost yard. Then the recycling center had been started in 2014 of April under the Polythene and Plastic Post-Use and Waste Management National Project of Central Environmental Authority. After that, as a long-lasting solution for garbage, attention had been paid to provide biogas and electricity using garbage in relation to that Kirula project, which was held in 2015. This project was carried out by Biogreen Cycle Private Company and Central Environmental Authority. Actually, that is the starting point of this landfill site. A part of compost yard had to be given for the construction of that project. So as a result of that, the compost production capacity was reduced and lot of waste amount finally disposed into landfill site. These are the calculation methods which I used for the estimation of greenhouse gas concentrations. They are based on IPCC 2006 waste model. For the impact assessment process, I use OpenLCA software. The databases are Agribalis and ELCD Green Delta databases. Let's see the results and discussions. Under the inventory analysis, here I show from this chart the available vehicle types and their quantities. For the calculation of transportation emission, first I got the average amount of diesel per month. Then it multiplied by carbon dioxide emission factor. Then that value is divided by average amount of waste treated per month. So the transportation emission per ton of waste is 11.1 kilogram of carbon dioxide. Then the greenhouse gas emissions from waste management practices was calculated based on 3 scenarios. Scenario 1, that is the baseline scenario. It indicates the current situation of waste management complex. Average amount of waste treated from recycling 2.8 tons, compost 1.46 ton, landfill 30.81. So greenhouse gas emission from scenario 1 is 772.25 kilogram of carbon dioxide per ton of waste. Then the scenario 2. In this scenario, the amount of waste that goes to landfill was reduced and amount of waste treated by composting process and recycling was increased. For recycling, that amount is 5.7 tons, composting 15 tons and landfilling 15 tons. So greenhouse gas emission is 475.886 kilogram of carbon dioxide equivalent per ton of waste. Scenario 3, new waste management practice was added, that is anaerobic digestion. For recycling 2.8 tons, anaerobic digestion 28 tons, and landfilling 4.24 tons. So greenhouse gas emission from scenario 3 is 242.571 kilogram of carbon dioxide equivalent per ton of waste. Then let's see the impact assessment. For the impact assessment, Recipe 2016 midpoint H method use. As I mentioned earlier, scenario 1 showed the highest amount of carbon dioxide emission. So as a result of that, in the global warming potential, scenario 1 shows highest result, and scenario 3 show the least result. Under the human health impact category, under the human health, I consider three main impact categories. They are ozone formation, fine particulate matter formation, and human non-carcinogenic toxicity. Under the ecosystem quality category, I considered ozone formation under terrestrial ecosystem, then terrestrial acidification, then freshwater eutrophication and ecotoxicity. So when considering about these impact categories, we can see scenario 1 show the highest result and scenario 3 has show the least result. Final step is interpretation. When compared with other scenarios, existing waste management practices which are practicing in Kothavila waste management complex show negative environmental impacts. The amount of waste that goes to landfill decreased, harmful environment impacts become low. In the scenario 2, the amount of waste that goes to landfill was reduced by, and compost and recycling amount was increased. And there, the environmental impacts was reduced, and that recyclable materials and produced compost can be used as good income source. In the scenario 3, the amount of waste that goes to landfill was reduced by introducing new practice, which is anaerobic digestion. It is the best option among these three scenarios. So the conclusion of this research is existing waste management practices in Kothavila waste management complex is contribute to harmful environmental impacts. It is possible to reduce those harmful environmental impacts by upgrading the compost and recycling processes. Combination of biogas production process with other waste management practices show significant reduction of harmful environmental impacts. These are the references. Thank you.
Okay, thank you very much, Ms. Kalhari. Actually, you have presented very good research findings here. Now the floor is open for the discussion. Any questions from the audience?
Thank you for the interesting presentation. What is the boundary of your LCA study?
Hello, good morning, madam.
What's the boundary of your LCA study? The boundary.
The boundary covers, madam, from waste collection point to their final disposal. Final disposal means landfilling, recycling, and composting. And suggested method is anaerobic digestion.
So, and also, how about the clinical waste management in Mathura? You haven't mentioned about it, I think.
The all waste they collect and finally they collect and also e-waste are there. They collect and dispose to Kothavila waste management complex. So there are no proper waste handling methods to separate waste.
So these hospital waste and e-waste, they are incinerating or how?
No incineration process happening, madam. They suggested to reduce those waste amounts. Suggested method is anaerobic digestion.
So, I mean the hospital waste.
Hospital waste. They told that in the hospital they are the waste management processes they practice to handle their clinical waste, in the hospital level.
No connection with this. Thank you.
Any other questions for Ms. Kalhari? Only one question is allowed, only 2 minutes are there. Okay, since there are no more questions, thank you very much, Ms. Kalyani, for your nice presentation. Kalhari, okay. Sorry
Thank
for the
you.
pronunciation. Okay, let's move to the third presentation. Assessment of major human impacts and the health of Kiralakale wetland using wetland classification and risk assessment index by NDL Nikavela and SV Jetunga. Yeah, Miss Nikavela. Yeah, you are going to present it.
Have a nice day, all of you. Today I am going to present research on assessment of major human impact and the health of Kiralakale wetland using wetland classification and risk assessment index. This is the outlines of the presentation. First, let's see about the introduction. Wetlands are defined as areas of marsh, fern, peatland or water, whether natural or artificial, permanent or temporary, with water that is static or flowing, fresh, brackish or salt, including areas of marine water, the depth of which at low tide does not exceed 6 meters. Wetlands are ecosystems whose formation processes and characteristics are determined by water. Wetlands are interface between terrestrial and aquatic ecosystems. Among the diverse ecosystems in the world, there is a particular focus on wetlands. Wetlands have been called the nature's kidney because they cleanse our environment. Wetlands are one of the most productive ecosystems for many biological species, including humans. Wetlands provide important and diverse benefits to people around the world. Wetland health is highly affected by rapid economic development, water pollution, overexploitation of natural biological resources, sedimentation, and habitat destruction. In many countries, the degradation of wetlands and associated impairment of ecosystem services can lead to significant loss of human well-being and the biodiversity. Protection and restoration of wetlands are essential for future sustainability of the planet. At present, a majority of the wetlands in Sri Lanka are adversely affected by human activities such as unauthorized filling, waste disposal, pollution due to effluent discharges, clearing of natural vegetation in and around wetlands, spread of invasive alien species, etc. This is the problem statement. A number of human activities resulting from socio-economic development are done without proper coordination and environmental impact assessment by various stakeholders. These activities are negatively impacting on the health of the wetland. It is important to assess the health of the wetland because it helps to maintain and further modify the health of the wetland. These are the objectives of the study. First one is evaluation of the health of Kiralakale wetland using the ESCOM's wetland classification and risk assessment index field guide. And second one is determination of major human impact on Kiralakale wetland. Let's see about the materials and methodology. The ESCOM's wetland classification and risk assessment index field guide was used to evaluation of the health of the Kiralakale wetland. Under this, there are several steps. First one is site selection. Name of the selected wetland is Kiralakale wetland. This Kiralakale wetland is made up of different types of wetlands, marshlands, mangrove areas, paddylands, and irrigation canals, as well as numerous home gardens as its populated villages. This Kiralakale wetland stands today as a key habitat for wetland biodiversity in the country. It lies between one of the longest rivers in the country and known as Nilgala River. Kiralakale wetland provides many benefits to communities and environment. Nilgala flood protection work, nature-based tourism, raising cattle, growing paddy and other crops, and fishing are some of them. This is the location of Kiralakale. And water samples collection and analysis. 12 number of samples were collected. Samples were collected from March to May. 3 replicates from each sample were collected within the western area of Kiralakale. These are the selected sampling points. Following standard sampling procedures, water samples were collected at the same water depth at all the 12 sampling sites. Samples were collected once per month. Collected samples were analyzed for following measurements: electric conductivity, pH, temperature, and dissolved oxygen. Then characterization of Kirlikale wetland based on physical and chemical characteristics. For that, field measurements were done to collect data on following: fogging, bank stability, presence of algae, macrophyte layers, and aquatic core percentage. Fogging. Fogging was measured using the number of tidal hook marks in a quadrant placed randomly on the sediment surface at the water's edge of the wetland. Bank stability was determined by walking around the wetland, and description was noted as stable, moderate, poor, or unstable. Macrophyte layers. Data was collected about macrophyte layers in or near water that are emerging, submerging, or floating on water. Aquatic core percentage, it was estimated visually by computing the percentage of water surface that was covered with aquatic vegetation. Aquatic plants include the emergent, submerged, and floating plants in the open water zones of the wetland. The amount of algae present in a sample area, it was assessed by making rapid appraisal wetland condition, physical measurement of the amount of algae present in a sample area. Then evaluation of Kirlikale wetland index score based on physical and chemical characteristics. This table shows different physical characteristics and their score value range. Then assessment of the health of Kirlikale wetland using the ESCOM's Wetland Classification and Risk Assessment Index Field Guide. Under this, the output score obtained the score sheet was transformed to a percentage by using this equation. Then the total percentage value was used to determine the ecological category of the wetland. This table shows different ecological categories based on the different score percentages. Then determination of major human impacts on Kirlikale wetland. For that, both primary and secondary data were used. Then let's see about the results and the discussion. These are the pH value that I collected for 12 sampling locations. pH is an important indicator of water that is changing chemically. In this study, combined mean pH is 7.12. According to that, combined pH for sampling site registered a score range is 4. These are the collected electrical conductivity values. Electrical conductivity is an important water quality measurement because it determines the amount of dissolved materials in the water. And mean combined electrical conductivity value is 0.56 millisiemens per centimeter. And then the registered score range is 3 on the field score sheet. And these are the collected dissolved oxygen values. The presence of a sufficient concentration of dissolved oxygen is essential to maintaining the aquatic life and aesthetic quality of wetland. Mean combined dissolved oxygen value is 2.48 milligram per liter. Therefore, registered field score range is 2 on the field score sheet. Macrophyte layers. In Kirlikale wetland, there are different macrophyte layers are available. Emergent plants, rooted floating plants, free floating plants, submerged plants are available in there. Fogging. Based on the field score sheet for the physical characteristics, the combined mean number of fogs per square meter is in between 1 to 6. Therefore, registered score range is 3. Bank stability was recorded as stable. Therefore, registered score is 4. Presence of algae. There was no presence of the algae in the wetland. Therefore, registered score is 4. And aquatic cover percentage was noted as less than 5. Therefore, registered score is 0. Then this is the calculated wetland index score range for each physical chemical parameter. This table shows the average score and the percentage index score. These are the major identified anthropogenic activities that may cause to the degradation of the Kirlikale wetland. Those are solid waste disposal, land reclamation, agricultural activities, removal of vegetation, land use changes, spread of invasive species, and animal poaching. And this graph shows the percentages of human activities around the Kirlikale wetland. And these are some of the photographs of the human activity that is carried out in the Kirlikale wetland. Solid waste dumping, agricultural activities, tourism activities, and then conclusion. The Kirlikale wetland could be categorized under the C ecological category. It means a moderately modified with moderate risk of the losses and changes in the natural habitat and biota in the wetland. And also, under this study, a number of anthropogenic activities are identified, such as agricultural activities, solid waste disposal, land reclamation, removal of vegetation, and spread of invasive species, land use changes, and animal poaching. These are done without proper coordination and environmental impact assessment by various stakeholders who live around the wetland, and those are negatively impacting on the health of the Kiralakale wetland. And these are the references. And thank you.
Okay, thank you very much, Ms. Nikavela, for your interesting presentation. Now the floor is open for the discussion. Any questions from Ms. Nikavela?
Yes, I have one suggestion actually.
Yeah. Yes, Kushan.
Ms. Nikavela, can you hear me?
Yes, sir.
Okay, so can you, okay, so since you don't have the presentation with you, so in your presentation, I noted that you have encountered different criteria in order to assess the risk, and also you have identified some risks associated with the wetlands. So I would like to suggest you to not only depend on the visual observation and try to quantify the impacts by providing some numerical weightage so that you can incorporate those magnitudes with the water quality and understand the true behavior of changes of the water quality in terms of those impacts, because visually, like from person to person, it can change. So, but I think it's always better to be more solid and incorporate some of the quantifications even in the impacts level so that you can go for more statistical analysis and justify your findings. So that's one of my suggestions for you study. Thank you.
Thank you, Kushan. Actually, any other questions? Yeah.
Thank you for the presentation. I have one question. So did you measure the BOD and COD values, or those are not necessary for the index?
No, madam, I didn't measure that.
It means no need for that index development.
This index, they are not measured COD and BOD. Therefore, I didn't measure it.
Did you conduct any type of questionnaire survey?
Yes, madam.
Thank you.
Okay, thank you, Ms. Kirtana. Any other questions? I have a question, Ms. Nikavela. Now you have listed there about some anthropogenic activities. How did you find those anthropogenic activities? By a survey or by literature or?
Some of the activities can be seen, madam, already when we are going to the wetland. And some others are fine from the literature and the survey also. Both are used.
You have done a survey?
Yes, ma'am.
Okay. Okay, it seems there are no more questions. So then thank you very much for your important presentation. Right? Okay, then shall we move to next one? Next presentation. Assessment of turbidity characteristics and water quality status of Maniganga in Katharagama Divisional Secretariat. The authors are HMLN Hera, TANT Pereira, WMCJ Vijayakon, RMPCS Ratnayak, and GY Jaisingha. Okay, I think Miss Herath is going to present it. Yeah. The floor is yours, Miss Herath. Yeah.
I'm going to my final year research presentation. My research topic is assessment of turbidity characteristics and water quality, Maniganga in Katharagama Divisional Secretariat. This is outlines, firstly introduction, problem statement, the objective of the study, materials and methodology, resource and discussion, and conclusion. Maniganga originated from Namunukula Mountain. Its total length of 140 kilometers and catchment is 1,272 square kilometers. Katharagama is a popular tourist destination. And annual rainfall is about 1,000 millimeter to 1,500 millimeters. Manikanga can be considered as the most worshipped river in Sri Lanka, and each year the Kataragama festival attracts 100,000 people per day and over 15 days period during July and August. This is my research problem statements. Negative effect, the turbidity, negative effect on aquatic animals and plants, and slow photosynthesis process and increasing acidity of water. This is objective of my research. The first one is measure turbidity level in water from Veheragala Reservoir to Kataragama Sanctuary, and to identify turbidity level and possible causes, to identify critical man-made issues, and to propose necessary recommendation for the recovery of water quality. Mainly we consider this study area 20 kilometer stretch from Veheragala Reservoir to Kataragama Sanctuary. And rainfall data gathered from Meteorological Department and Irrigation Department. This is a water sampling and analysis. Samples were collected between January and May, from January to May, and I measured temperature, turbidity, pH, electrical conductivity, total dissolved solid, and total suspended solid. And sampling location were identified using Hydro Tool of ArcMap software, and from Google Earth Pro software were used. And in the field, pH, temperature of water sample, hydrological, topographical, and geological condition have been recorded in my field survey. I prepared questionnaire using ODK software. A total of 147 people were interviewed to get their views about the water quality, and a face-to-face interview was conducted to gather information, as it gave more flexibility to both interviewers and participants. And this is research and discussion in my research. Soil condition is a soil of Kataragama area belong to Mahagalara series. It contains clay percentage more than 30% in the subsoil. The picture shows soil profile exposed by erosion. And although the pH is slightly alkaline, it remains almost uniform along the stretch during each sampling event. The site 0, I mean Veheragala Reservoir, is pH is very low. The electrical conductivity also fluctuates slightly along the studied stretch in each sampling event. This is variation of total suspended solids. A sampling site 0 is a reservoir. Total suspended solid level is very low, and sample points 7, 8, and 9 is total suspended solid content is very high, because reservoir promote the release of sedimented soil particle along with the discharge. And this picture shows variation of turbidity along the study stretch of Manikanga. Reservoir turbidity is very low, and site 4, 5, 6, 7, 8, and 9 turbidity is high. Sampling site 4, turbidity level is 80. This site mixing and agitating of water by turbulent section of river. And site number 5, this site was agricultural activities, soil erosion and sediment to river, and extensive sand mining. This is my questionnaire research. Firstly, clarity rate. And 41% people moderate, and some people very clear and poor. This second picture shows satisfied with water quality. And this is Manik River is the most polluted river in Sri Lanka. 38 people are agreed in this this sentence. Manik River is the most polluted river in Sri Lanka. Another picture show based on long-term observation trend of water quality. And this is my other observation in my research. No protective vegetation in Manikanga. Too heavy erosion during storm flow, and large number of buffalo used to bathe in river, and excessive soil erosion, illegal sand and gem mining activities, and releasing agricultural runoff to the river. This is conclusion of my research. The process of sand mining along feeder stream and the river, and long-term data about the water quality and its relation to rainfall, the range of suspended particle sizes, construction detail of the Veheragala Reservoir and its impact on sediment loading, sustainable measures to protect stream banks from erosion, and avenue of upgrading the livelihood of dwellers of the area while protecting the riverine environment. This is my references, and thank you, everyone.
Thank you very much, Ms. Hera, for your interesting presentation. Now the floor is open for the discussion. Any questions for Ms. Hera?
Madam, I have a question.
Yeah, sure.
Thank you, Herath, for your interesting presentation. So what are your recommendations to the relevant authorities or relevant people? What are your recommendations to this? What you can say from your conclusion of the study?
I recommend some vegetation, plant vegetation and protect sand mining in some places.
That's all?
And prohibit some construction buildings and sustainable measures to protect stream banks from erosion.
So what you can do, only can make recommendations. So what is the way forward?
Sorry, madam.
So what is your way forward? You're only going to make recommendations. So you have any plans?
No, madam.
Okay, thank you.
I think Kushan also had.
Yeah, I had one question actually. So what is your sample size, sir? The number of replicates for your study?
4 replicates.
4 replicates. And I think in terms of understanding the changes of variation of parameters, you can do a trend analysis. So it would be better so that statistically you can understand what is the trend rather than just putting the graphs. Better to follow the trend analysis and better to justify your results with the statistical analysis. Okay. So I think, yeah, since you have 4 replicates, you can correctly do the trend analysis calculation and perform that one so that it will be more solidifying your findings.
Okay, sir.
Madam, I also have a question.
Yeah, sure, Anupa. Thank you, Kushan.
Okay.
Yeah.
Thank you for the nice presentation. So I would like to know the range was 20 kilometers, right? 20,
yes, sir.
Yeah, and the sample taking locations, did you divide like 2 kilometer, or you choose randomly 9 places? Is it like
randomly selected, sir?
Randomly. So randomly means like, did you consider about that some areas may be nearby some areas may be more polluted than the other areas, right? So how did you choose that? Or you just, how did you choose? Just randomly?
I am joined my research in Central Environmental Authority Mondragal officer. Their field officer was selected in this location.
Okay, thank you.
Okay, since the time is, no, we have enough time for another question. Any other question for Ms. Hera?
So one more question, madam.
Yeah.
So the stretch is about 20 kilometers, right? That area considered?
Yes, madam. 20
Do you
kilometers.
think the sample collection from 9 sites is representative of the site?
Sorry, madam.
So you have taken samples only from the 9 sites, right? Do you think that 9 sites will be representative of that entire area?
Yes, madam, yes. Site number 0 is a reservoir. And site number 9 is Kataragama town.
So you mean you have covered all the areas?
Yeah.
Okay.
Okay, thank you very much. All participated for the discussion and Miss Nikavela, Hera, sorry, Miss Hera. Now we'll move to next presentation, presentation 5. Comparison evaluation of treatment efficiency of conventional activated sludge process and membranes bioreactor, a case study in Kilinochchi. A. Reginton, S. Vijayatunga, and A. Joyce Aniston. Reginton, floor is yours. Hello. Anushka, are you playing that one? Yeah.
Good morning to you all. I am Rajindan. Here today I present my research topic is comparison evaluation of treatment efficiency of conventional activated sludge process and membrane bioreactor, a case study in clinology under supervision of Mr. Professor S. Vijayatunga and Mr. Joyce Aniston. These are the content of today's my presentation. Let's see the introduction. Sri Lanka is an agricultural island. So the water resource used for not only cultivation but also electricity generation, industrial purposes, and people daily needs. At the same time, water loss and water pollution also increasing. As a result, part of the water become wastewater in large quantity. Wastewater is a gray turbid liquid. Sometimes it has bad odor, and it has contain variety of polluting substances such as inorganic substances, heavy metals, fecal solids, microorganisms, garbages. Nowadays, wastewater disposal without hazard has become a major issue. So, wastewater need to be treated properly. If not, it creates a lot of negative impacts on environment, such as waterborne diseases, dead zones, eutrophication, threatening to living organisms. Wastewater treatment defends humans and ecosystem from the hazards and toxic elements. The activated sludge process is a conventional biological treatment process. In activated sludge process, aerobic microbes digest the degradable organic matters into soluble form. Currently, a lot of the wastewater treatments are available all over the world. In Sri Lanka, conventional activated sludge and membrane bioreactor technologies are more available in present. CA is a very simple mechanism, but it has some drawbacks also. Mainly, it cannot manage with either composition of wastewater or fluctuation of wastewater flow rate. Today, conventional water treatment methods have been improved as a new membrane filtration technology. And membrane bioreactor technology is a combination of biological digest and microfiltration. Advantage of my MBR is require less place and produce lower sludge volume. Main drawback is higher cost and require trained workers for the operation. These are the process flow diagram of activated sludge process and membrane bioreactor process. Now the problem statement. Sri Lanka currently faces many water and wastewater related issues and health hazards. The treatment plant does not meet the effluent standard because of poor condition of wastewater treatment system, inappropriate design, administrative problems. And so performance evaluation is required to enhance the effluent treated water quality as environmental friendly, be economically sustainable, and possibly handle higher organic and hydraulic load. These are the objective of my study: to determine the treatment efficiency of membrane bioreactor, to determine the treatment efficiency of conventional activated sludge, and to compare the efficiency of two treatment systems with respect to treatment rate, treated water quality, cost, and the energy efficiency. Now see the material and methodology process. I conduct the research as two ways. First, data collection and primary data analysis. At the parallelly water quality analysis. After that, finally, evaluate the result. Study area. My study area is Varnaville plant. The situated Varnaville plant, membrane bioreactor plant are situated in Varnaville, and CS plant situated in Hagil School Supply. Both plants are situated in the same place in Klinochi district. This is the schematic diagram of membrane bioreactor wastewater treatment plant. And this one is the schematic diagram of CAS wastewater treatment plant. The first process is the primary data collection. Primary data is collected from the inspection and the activities of each water treatment plant activities, such as operational cost, the energy consumption, need chemicals, their quantity and their price, flow rate, and the reusing detail of the treated water. This data collection was done based on the last previous year record. Next one is the sampling. Composite type water samples were taken for the analysis. Samples were collected from the influent raw water and effluent treated water in high density polyethylene bottles. Data collection and testing. Samples were analyzed as illustrated the standard techniques in testing in our faculty laboratory. 2 replicates were considered from the each sample. The samples were analyzed for various parameters, such as electrical conductivity measured by the calibrated conductivity meter, pH was measured by the calibrated pH meter, BOD was measured by the tritymetric method, total suspended solid and total dissolved solid was determined by the gravimetric method, ammoniacal nitrogen and nitrate nitrogen were determined by the ultraviolet spectroscopic method. Now see the results and discussion. First one is the energy consumption. Energy consumption of membrane bioreactor and conventional activated sludge was measured continuously for 45 days from 14th of February 2022 by an electrometer. The average energy consumption for MBR plant is 174.75 kilowatt hour per day. For CAS, 87.74 kilowatt hour per day. You can see the daily average consumption rate in both CAS and MBR plant in this graph. CAS has low energy consumption than MBR as from our analysis. CAS produced 684 liters treated water in 1 unit of electricity. MBR produced 630 liters treated water in 1 unit of electricity. Next one is the cost. Some assumptions were taken for the cost analysis, such as the cost of an electricity unit is 12 rupees and 20 cents. Maintenance cost includes staff salary and water quality test report cost, and no inflation during my research study period. In this graph, represent the factors and total cost their contribution of CAS and MBR plant. Electricity cost is very high in all over the coast. From the analysis, CAS need low cost than MBR for treated 1 meter cube wastewater. In this table, show the mean value with standard deviation of all parameters and their tolerance limit of effluent. Next one is the pH distribution. The pH was measured by the calibrated pH meter and range of pH distribution from 5.84 to 8.43. Effluent standard is upper tolerance limit is 8.5 and lower tolerance limit is 6.0. You can see the pH distribution of both CAS and MBR plant. Most of the values are between the tolerance limit. Next one is the electrical conductivity. The figure shows the electrical conductivity of influent and effluent water of MBR and CAS plant. The range between 0.83 millisiemens per centimeter to 1.54 millisiemens per centimeter. Next one is the BOD. This graph displays the trend of BOD5 values of conventional activated sludge and membrane bioreactor during the experiment. The range between 77 to 132 milligram per liter. In this graph, you can see the removal efficiency graph. Membrane bioreactor plant always remove BOD at more than 85%. Next one is the total suspended solid removal. In this graph, it can be clearly seen the corresponding value of total suspended solid of raw wastewater. The maximum average concentration of total suspended solid was 692 milligram per liter and the minimum 410 milligram per liter. Next one is the total dissolved solid. It can be clearly seen that corresponding value of total dissolved solid of the raw wastewater, the maximum average concentration of total dissolved solid was 1500 milligram per liter and the minimum 900 milligram per liter. You can see the removal efficiency of total suspended solid and total dissolved solid in this graph. Ammonical nitrogen. The figure represents the ammonical nitrogen value of influent and effluent water of CAS and MBA plant. The range between 11.10 milligram per liter to 38.12 milligram per liter. Next one is the nitrate nitrogen. The figure represents the nitrate nitrogen value of the influent and effluent water. Range between 3.832 milligram per liter to 9.5 to 6 milligram per liter. This graph show the removal efficiency of both nitrate nitrogen and ammonical nitrogen. This table shows the wastewater characteristic range in my research study period and both MBR and CAS plant. During the whole operations, no fuel usage during their operations. Whole treated water was used for their own irrigation purpose and toilet flushing inside the industry. Effluent sludge is used as a dry fertilizer for their gardens. The statistical comparison of efficiency between CAS and MBR plant, the data were subjected to two sample t-test and basic descriptive statistics using Minitab version 90. A probability of 5% was used to compare the means of treatment to identify the significant difference. All the parameters are significant except the electrical conductivity. This is the summary of all removal efficiency. You can see then in this picture, TDS and EC are very less removal efficiency compared to the other parameters. Finally, the conclusion. Membrane bioreactor can treat large quantity of wastewater more than CAS plant. CAS need low energy and low cost for the treating 1 meter cube of wastewater than the MBR plant. Both CAS and MBR system remove the electrical conductivity and total dissolved solid at the low efficiency. Membrane system remove the BOD5 value, total suspended solid, ammonical nitrogen and nitrate nitrogen at high efficiency rather than CAS during the whole operation time. Both CAS and MBR plant effluent quality was made suitable for the treatment of industrial wastewater and water reuse with maintaining their effluent quality under Central Environmental Authority standard. These are the reference, and thank you for listening.
Thank you very much, Rajintan, for your interesting presentation. You have took about 12 minutes. And yeah, now the floor is open for the discussion. Any questions from Rajintan? Sorry. I have a question, Rajintan.
Yes, ma'am.
In your title, you have mentioned comparison evaluation of treatment efficiency of conventional activated sludge and bioreactor, membrane bioreactor. Now, in the conclusion, you say both are same, like that. That by comparison, you are not going to say this one is better and that one is not that much better, like that.
Yes, miss. My conclusion is finally conventional activated system is more suitable for the treatment medium scale wastewater treatment in the term of energy and operational cost.
Okay, but volume of water.
According to the
case also that one is better.
Yes, miss. That one is CAS plant is better than MBR according to the energy and operational cost. But we consider the water quality, the MBR is more better than CAS.
Okay, thank you. Any other question for
Yeah, madam.
Yeah.
I'd like to know from Reginton that after treatment, for what type of purpose this water is used? This was
Sorry, sir.
after treatment, you said that it's we can use that water for some purposes, right? So what
Yeah,
are
yes.
what kind of purpose?
Yeah, so the all treatment plant used for their own purpose, but for gardening and the toilet flush.
Okay, okay.
Okay, thank you very much, Reginton. Sorry, when I pronounce your name, sometimes I make the mistakes. For your nice presentation. Let's move to next presentation, presentation 6. Determination of environmental impacts of chicken production using life cycle assessment. A case study in Vaunia district for backyard chicken and broiler chicken by N. Muthu Kumaraswamy, K. Kumareswaran, and J. Vijayaratna, and S. Vijayatunga. Yeah, now floor is for you, Miss Muthu Kumaraswamy.
Good day to you all. I am Nivedini Muthukumarasamy. My topic is determination of environmental impacts of chicken production using life cycle assessment, a case study in Vaunia district for backyard chicken and broiler chicken. Let's see about the introduction. The livestock industry's growth and demand increases annually, resulting in environmental consequences. Among the poultry industry, chicken production is globally widespread, with significant levels of meat production in Southeast Asia in terms of the number of broiler flocks. With a greater understanding of the need of environmental protection and the possible risk of products, life cycle assessment is one of the methodologies to better understand and solve the consequences. Chicken supply chain is one of the well-established livestock sectors in Sri Lanka. Life cycle assessment can help with identifying opportunities to improve a product's environmental performance at various stages of its life cycle. This is a basic layout of poultry farming. Let's see the problem statement. There are limited number of poultry farms in Vaunia district after the economic crisis. In the poultry farming, backyard and broiler chicken farms are mostly available for the chicken production than other breeds. Most of the farmers involved in chicken production are not aware about the environmental impacts of different stages of the chicken production. Therefore, determination of environmental impacts at different stages of chicken production is very important. Then producers can find the appropriate new methods and technologies that can reduce the environmental burden in chicken production. Let's see about the objectives of the study. First one is to determine the environmental impact of chicken production using the life cycle assessment of backyard and broiler chicken farms. Second one is to compare the environmental impacts within the backyards and broiler farms separately. In the selection of study area, I selected 8 broiler farms and 8 backyard farms which are located in Vaunia district. These are the names of the farms which I selected. These pictures shows the broiler farms. These are the pictures about the backyard farms. In data collection, data of inputs, outputs, and processes related to the relevant poultry farms are collected through previous records and live recordings in the farms. Information related to the emission factors and calculations of selected categories are collected through the literature review. These are the input and output data which are collected from the farms. All the environmental impacts are calculated through the manual calculation. Let's see about the stages of life cycle assessment. First one is the goal and scope definition. Goal is to assess and compare the environmental impacts of backyard chicken and broiler chicken production separately throughout their life cycle. The system boundary is cradle to gate before slaughterhouse.
Functional unit is 1 kilogram of live chicken production. In the life cycle inventory analysis, electricity, fuel consumption, and water use throughout the life cycle of backyard and broiler chicken are collected separately. Broiler feed consumption are collected from the farms and backyard feed consumption are calculated by the calculations. CO2, CHO, and N2O are the direct emissions from electricity and fuel usage, which are calculated manually with the aid of the literature review. In life cycle impact assessment in this research, first three mandatory elements are taken into consideration. They are selection of impact categories, classification, and characterization. Let's see about the impact categories. First one is the global warming potential. These equations are collected for the calculation from the literature review. These are the data tables which are collected from the literature review for the calculations. In water use, total amount of water use of chicken production are calculated by using the capacity of the buckets which farm owners used. Main purposes of water consumption in selected farms are drinking, cooling, cleaning, and azolla culturing. In fossil energy use, direct and indirect use of fossil fuel are considered here. Main purposes of fossil energy consumption in selected farms are electricity and fuel use. In feed conversion ratio, it measures an animal's ability to convert feed into body mass. This is the equation for the broiler farms. For backyard farms, it is calculated by dividing the dry weight matter of feed by the dry weight matter of eggs, which are produced over a given time interval. This table shows about the emissions of transportation and electricity use in broiler chicken farms. These charts describe the above table. This table shows the emissions of transportation, electricity, and generator use in backyard chicken farms. This chart describes the above table. These are the final results of broiler chicken farms. These are the final results of backyard chicken farms. This chart shows the total emissions of the broiler farms. This chart shows the total emissions of backyard chicken farms. This chart describes about the total water use in the broiler farms. This chart describes about the total water use in the backyard chicken farms. These are the types of fuels used in broiler farms. These are the types of fuels used in backyard farms. This is the final results of feed conversion ratio of broiler chicken farms. This is the final result of feed conversion ratio of backyard chicken farms. This chart shows the total feed conversion ratio of broiler farms. This chart shows the total feed conversion ratio of backyard chicken farms. These are the final results of broiler farms. These are the final results of backyard chicken farms. Let's see about the conclusion. In most cases of this study, greenhouse gas emissions from transportation process are higher than the other processes, reporting 71% and 64% of total greenhouse gas emissions in broiler and backyard farms respectively. In broiler farms, transportation is used to transport mash, bedding material, one-day-old chicken and adult chicken. In backyard farms, transportation is used to transport eggs, chicks, bedding material, food, and adult chickens. The amount of energy utilization can be reduced by effective planning. All the procedures should be planned well to avoid unnecessary usages. It will reduce the greenhouse gas emissions. In both broiler and backyard farms, cleaning and drinking purposes are identified as most water consuming methods. Broiler farms contribute for 65% and 34% for the cleaning and drinking requirement, whereas backyard farms account for 35 and 58% respectively. Utilizing the least amount of water is recommended to save water. However, it shouldn't affect the performance of the farms. Due to the lack of awareness, majority of both backyard and broiler farms use excess water for the cleaning purpose. If the water usage for cleaning purpose is metered daily, farm owners can therefore understand their usage and reduce it. The broiler farms have an average feed conversion ratio between 2.07 and 1.21, while backyard farms have an average between 1.029 and 2.75. The lower feed conversion ratio means higher efficiency. If the FCR increases, greenhouse gas emissions will be increased. With the aid of the calculated value, feed conversion ratio can be minimized by adjusting it within the limits. It can also be improved through the diet formulation, good water and feed management, good farm management, and keeping the environment in ambient temperature. These are the references which I use here from the literature review. Thank you.
Okay, thank you very much, Ms. Muthukumara Swami, for your presentation. Actually, I didn't see discussion there, the results and the conclusion. Anyway, okay, now floor is open for the discussion now. Okay, any questions for Ms. Muthukumara Swami?
I have a question, madam.
Yeah.
So thank you, Muthukumar, for your interesting presentation. So what is the total greenhouse gas emission per kilogram of backyard and broiler chicken? I couldn't find it anywhere. Can you hear me?
Hello, yeah, I can hear you. Ms. Muthukumara Swami, are you there?
Yeah, yes, madam.
Yeah. Please
So what is
answer.
the total greenhouse gas emission of broiler chicken?
The
And
total greenhouse gas emission, yes, madam. Total greenhouse gas emission of broiler chicken is 0.1836 kilograms CO2 equivalent per 1 kilogram of live chicken, and backyard chicken is 0.5471 kilograms CO2 equivalent per 1 kilogram of live chicken.
so how reliable is your research? Because you didn't compare the results obtained with any other research findings. So how about other researchers? They have obtained the similar values so far deviating from yours? So did you refer the other researchers conducted for this broiler or backyard?
Yes,
They
madam.
got the same
They
values?
deviate from my research. They deviate from my research because they considered the production of feed. They include that in the greenhouse gas emission. That is the deviation from this research.
It means your system count is different.
Yes, madam. Because in greenhouse gas emission for the feed production.
So how about is there any significant difference between the backyard chicken and broiler chicken in terms of greenhouse gas emission, or almost same?
In this, I considered 40 days for the broiler chicken. I 24 weeks for the backyard chicken. So it will differ based on the days I considered.
But your functional unit is per kilogram of live chicken, right?
Yes, madam.
But due to the difference in number of days, you didn't compare.
Yes, madam. Because the feed consumption methods are different from for both chicken types, and also the days I considered also different.
Okay, thank you.
Okay, actually, yeah, thank you, Kirtana, for your questions. You should be able to discuss your results with past literature and things, and you have to say something. But here in your presentation, we couldn't find them. Anyway, the time is up. So thank you very much, Miss Muthukumara Swami. Thank you. Then let's move to the next presentation. That is 7, development of natural top coating material for soil concrete floor by LPCN Patirana, GH Galabada, RU Halvatura, and GY Jaisingha. Miss Patirana, Miss O, Mr. Floor is yours.
Have a nice day, everyone. My topic is development of natural top-coated material for soil concrete floor. I would like to move on introduction part. Coating. Coating is a material that covers and protects the substrate surface from environmental exposure. Advantages of coatings are extended life of surface, aesthetic appearance, prevents surface from physical, chemical, and biological damages. Compounds of coatings are binding agents, pigments, fillers-like things. Considering about synthetic coatings, they have various polymeric resins, epoxy, polyurethane like things. And also, disadvantages of synthetic coatings are they based on petroleum-based stocks, it creates so many problems. Mutagenic and carcinogenic problems like health effects and ozone depletion like environmental effects. At that time, if we can develop coating material based on natural substances such as plant extracts, it exactly reduces the use of toxic chemicals. Advantages of plant extracts are non-toxic, eco-friendly and safe to use, and also they have excellent properties like anti-corrosion, antimicrobial, anti-fouling, self-healing and UV shielding properties. Finally, soil concrete floor is a sustainable construction concept that has more positive characteristics. But the problem is mold growth, and up to now it was used synthetic coating as a top coat. Urgent need is find possibility introduce natural coating instead of a synthetic coating. Problem is statement directly based on synthetic coatings. They have different volatile organic compounds as well as toxic artificial additives like heavy metals. Both of them affect for health and environmental degradation. Objectives of the study are develop a natural top coating material and investigate their performance. Methodology divided into 3 sections. First one, prepare soil concrete floor samples. Second one, prepare and apply natural coatings on soil concrete floor samples. And finally, check properties of floor with natural coatings by using tests. Before the coating material development, wanted to prepare soil concrete floor samples. According to that, soil concrete mixture preparing according to these percentages, sample prepare according to the small size, 24 hours keep demolding, 28 days keep for casting, grounding by grinder, apply clay cement plaster, and finally we can get a smoothened surface by sandpapering process. Under the coating material development, follow trial and error method. First coating type is banana peels. This is the procedure for that. Firstly, washed banana peels with distilled water, oven dried them 60 Celsius 18 hours, crushed and sieved, immerse saline in 3 days, powder to saline ratio 1 to 30, sieved by using thin cloth. Coating preparation procedure is add these aqueous extract into the acrylic resin according to the weight percentage 50, 70, 90 and 30 percentage. After that, they stirred by using magnetic stirrer at 20 min room temperature to get homogeneous blended mixture. These are the observations of banana peels coating. Henna leaves coating, extraction procedure and preparation procedure as same as previous, but the difference is use sterilized water instead of banana peels coating. These are the visual observations of henna leaves coating. Dummel and Dorano oil coating at 125 milliliter Dorano oil, 250 gram powder of dummel and boil this mixture. They cooled at room temperature. Add again 125 milliliter Dorano oil to mixture. Apply first coat, second coat. Finally, it keep dry and applied acrylic resin layer. These are the application test procedures. Full of test according to this stand determine bonding performance. Metallic plate was used. The dimensions are mentioned in here. Test area was cut with a 5 mm deep cut and square shape. Metal plate was glued by using rapid setting epoxy on the soil concrete floor samples. Loading mechanism was done by using universal testing machine. This is the universal testing machine. Visually, surface fracture pattern, flow sample and leak pad were observed. If full out failure occur through the soil concrete base, it is pass. If full out failure not occur through the soil concrete base, it is fail. 2 replicates were considered. Water absorption test according to this standard in here determine water resistance. Test was carried out 23 Celsius tap water. Side surface of each specimen was sealed with paraffin wax. Record the weight of the samples nearest 0.1 gram and initial time was recorded. After 5 min, take the weight of the samples and after that subsequent measurement were recorded at 10 min, 30, 60, 120, 180, 360 min and finally after 24 hours. 2 replicates were considered. Under the stain resistant test according to this standard, determine stain resistance. In here, use drop of potassium permanganate and methylene blue. After that, they put on the surface. After 24 hours, they were washed out with pure water and surface was observed. If discoloration patch observed on the original 4, it is pass. Discoloration patch not observed in the original 4, it is pass. Discoloration patch observed in the flow, it is fail. 2 replicates were considered. Under the results and discussion, banana peels coating, henna leaves coating and dummel and Dorano oil coating. These are the observations of after applied soil concrete flow samples. Full of test. Henna leaves, banana peels and dummel and Dorano oil coating. 50-50 percentages failure pattern occur through the soil concrete base. According to that, they were properly bonded to the base of soil concrete. coating with 30, 70, and 90 were not properly bonded to the base of soil concrete. Banana peel coating and henna leaves coating observation were same. Under the water absorption test, in the banana peels coating and henna leaves coating, highest weight increment percentage nearest 0.2 percentage, and Dumbel and Dornoil highest weight increment percentage nearest to 0.12 percentage. In these three coating types, after reach the highest weight increment, there is no any weight increment. And these three coatings, compare with the no coat, they were negligible. Water absorption by coating was considered the first stage of their degradation. A comparison of water absorption with no coat shown that water absorption was highly influenced by the prepared top coatings. The water absorption of these three coatings negligible for these three coatings. But water absorption of all percentages of banana peels and henna leaves coatings were shown closer increment value. These closer increment values were negligible among each concentrations. The water absorption of samples without coating were very much higher than that of samples with coatings. Therefore, these top coats effectively provide the ability to water repellent properties. Under the stain-resistant test, all banana peels coating, henna leaves coating, and Dummel and Duranoil coating were no any discoloration patches. According to that, these three coatings were virtually impenetrable for those stains. It would be near impossible for these tested chemical solution and any other liquid to leave a mark on its surface. This is the conclusion. Banana peels, henna leaves, and Dummel and Duranoil coating have the feasibility to develop coatings for the soil concrete floor. Coating with 50-50% banana peel and henna leaves coating and Duranoil coating with alkaline resin layer were shown good bonding performance, and all coating types were shown effectively provide the ability to water repellent and stain resistant properties. Overall, this study will provide eco-friendly, economically sustainable alternative coating for the newly soil concrete floor, while giving a new direction to floor finishes in the civil construction industry. Future directions are slip resistance and wear resistant test must be done and further development of these coatings. These are the references.
Okay, thank you very much, Ms. Patirana, for your interesting presentation. Now the floor is open for the discussion. Any questions for Ms. Patirana?
So I have one question. So Ms. Patirana, you did present your research finding very well. Thank you for that. So I want to ask, so did you encounter any limitations in using plant-based coating materials in your study? So you were talking about the advantages. So did you encounter any drawbacks or limitations in using plant-based materials?
Sir, plant-based materials are degradable, but I try to use acrylic resin to remove that drawbacks. Therefore, I didn't find out any limitation. But in the whole research, I can't do slip resistant and wear resistant test because of lack of facilities. If I can do that, it is very good. And other thing is, if I can add some color agents, it is very good, sir.
And also, I noted that in your presentation, you were trying to mix different ingredients in different ratios to make this coating. So, did you require any literature related to that, or how did you do that?
Yes, sir. I find out the literature in Malayasian research. Henna leaves extract with acrylic resin and banana peels extract with acrylic resin. They were it apply to the metal structures. So these percentages, and they find out better percentage. I try to the best percentage for that and possibility to use these coating for the soil concrete flow.
Okay, that's good. Okay, good luck with your future activities. Thank you.
Thank you, sir.
Thank you, Kushan, and thank you, Ms. Pathiran. Again, actually, very good discussion there. Yeah, I also had a question, but I got the answer there, right? Okay, then thank you very much. So let's move to next one.
Thank you very much, madam.
The next one is effect of green infrastructure on air quality levels in urban streets and across the different vegetation patterns. The authors are H.A.T.N. Pereira, K.G.H.N.H. Veerasinghe, R.U. Halwatura, and G.Y. Jaisinghe. Ms. Pereira, here. The floor is open for you.
I am H.A.T.N. Pereira. My topic is effect of green infrastructure on air quality levels in urban streets and across the different vegetation patterns. This is the outline of my presentation. Let's go through the introduction. According to WHO, air pollution is contamination of indoor or outdoor environment by any chemical, physical, or biological agent that modifies the natural characteristic of the atmosphere. According to that, air pollution is one of the most significant consequences of our era. Nearly polluted air suffocate 7 billion people across the globe per year. According to previous studies, 90% of people breathe air that exceed the WHO preferred pollutant levels. Those are mainly from middle and low income countries such as Sri Lanka. The transportation sector is responsible for growing portion of urban air pollutants. The layout of characteristic of plant barriers are efficient for lowering pollutant concentration in local urban streets. This figure shows how the pollutant concentrations are influenced by the permeable linear barrier or H. This figure shows how direct and indirect air pollution reduction strategies used by trees. According to that, we can transform polluted atmosphere to purified atmosphere by usage of indirect air pollution reduction as well as direct air pollution reduction. In the indirect air pollution reduction, we can reduce carbon dioxide by photosynthesis. In the direct air pollution reduction, we can reduce particulate matter by using the dispersion speed changing usage of capturing and deposition. Let's go through the problem statement. Most studies have been done to determine the role of carbon dioxide as well as particulate matter in the air pollution. And also those are related with how vegetation cover affect air pollution mitigation in contaminated areas. But the issue is that when building or designing a town, the distance from the road for the safe placement in relation to air quality is not sufficiently approached so far. These are the objective of my study. First one is to measure the carbon dioxide and particulate matter in roadside. Second one is to assess vegetation combination to reduce carbon dioxide and particulate matter related to air pollution. Third one is to enhance knowledge in carbon dioxide and particulate matter in transportation sector as well as to influence the greenery on computing the road building spacing. Let's go to the materials and metallurgy. This methodology is developed by previous studies. These are the tools that and the instruments that used to collect data. This shows what are the tools that used to data interpretation and analysis. Let's go to the location selection. According to previous studies, there can be some kind of effect in evergreen and coniferous plantations to mitigate air pollution. Therefore, I considered grass cover and tree canopy, meadow tree cover, tea plantation, and fruit plantations as evergreen plantations, and also pinus, red gum, as well as turpentine plantation considered as coniferous plantations. According to fruit plantations, those are having some kind of different effect in PM in normal condition and flowering season. These are the actual photos of those places. These are the location sketches. Let's go through the results and discussion part. In here, I'm considering 5 configurations. Those are can be named as grass cover and tree canopy, tea plantation, coniferous plantation, Mara tree cover, as well as fruit plantation. Let's go to the results related with considered pollutant level in the road. This graph shows how PM1 and optimum PM1 relation in the normal condition for the non-flowering season. This is with the PM2.5 and this is with PM10. This graph shows how all PM types variation with the considered pollution level on the road. As I mentioned earlier, some kind of effect that can be seen in the flowering season in fruit plantations. Therefore, this graph shows how PM1 and optimum PM1 level variation in flowering season in fruit plantations, as well as this is with PM2.5. This is with PM10, and this shows how all PM types variation has been done. This graph shows how the normal condition carbon dioxide variation in optimum level variation. These optimum carbon dioxide and optimum PM levels has been discovered by the WHO 2020 guidelines. Let's go through the results part in the vegetation barrier distance to be established. According to that, I am considering normal condition as well as flowering season. When this graph reaches to 200 meters, there can be seen some location can't reach optimum level with the present vegetation coverage in some fruit plantation sites and other sites. And this is related to the carbon dioxide. This is with PM1, this is with PM2.5, and this is with PM10. As I mentioned earlier, there can be seen some kind of effect in fruit plantations in flowering season. This graph shows how the distance variation to establish aspect of all PM types in the flowering season. Let's go through the discussion part. According to that, grass cover and tree canopy combination, we can establish 150 to 170 vegetation barrier lengths related with Ruhuna, Mara finus to align with the optimal level of all PM and carbon dioxide pollutant levels. When considering coniferous plantation, we can establish 100 to 150 vegetation barrier length in monocrop. Those monocrop can be combined with serpentine, pinus, and red gum. By usage of those things, we can align with the optimal level of all PM and carbon dioxide pollutant levels. When considering the tea plantation, 100 to 150 vegetation barrier length can be established to align with optimal level of all PM and carbon dioxide pollutant levels. In here, main crop is the tea. When considering the Mara tea cover plantations, those are already in the optimum level of all PM and carbon dioxide pollutant levels. Therefore, I would like to recommend 5-meter vegetation barrier distance can be enough to meet those optimal levels. And also, those can be related with Mara, and pinus. When considering the fruit plantation, as I mentioned earlier, there is some kind of effect in PM in non-flowering and flowering season variations. Therefore, we can establish 150 to 120 vegetation barrier lengths related with fruit plantations. Those plants can be combined with rambutan, mango, avocado, guava, banana, and jackfruit plants to meet optimal level of carbon dioxide and all PM levels. Let's go through the conclusion. According to Objective 1, we can see PM1 is lower than PM2.5 and PM10 is higher than PM2.5. This variation can be seen in units of microgram per cubic meter. According to WHO Air Quality Standard 2020, in the aspect of carbon dioxide, we can see 17 sites out of 20 sites are aligned with the threshold level. And also in the aspect of PM10, we can see 10 sites out of 20 sites are lower than the threshold level in non-flowering season, and 3 sites out of 5 sites are lower than flowering season. And also when considering the PM2.5 aspect, we can see 9 sites out of 20 sites are lower than threshold level in non-flowering season, and the 5 sites are higher than the threshold level in flowering season. And when considering the PM1 aspect, we can see 9 sites out of 20 sites are lower than threshold level in non-flowering season, and as well as 5 sites out of 5 sites are lower than the threshold level in flowering season. According to Objective 2, we can establish fruit plantation and Mara cover as best vegetation barrier to reduce particulate matter-related air pollution. And also we can establish grass cover and tree canopy combination as well as coniferous plantation as best vegetation barrier to reduce carbon dioxide-related air pollution. According to Objective 3, we can establish 100 to 150 vegetation barrier length to meet all PM and carbon dioxide related optimum levels. This is the final conclusion of my research. According to that, we can establish 100 to 150 vegetation barrier length to meet optimal level of all PM and carbon dioxide contaminated related air pollution reduction. And also we can establish food plantation and moratorium cover combination to reduce particulate matter related air pollution, as well as carbon dioxide related air pollution reduction can be usage of grass cover and tree canopy and coniferous plantation. These are my references, and thank you. Hello everyone.
Thank you very much, Ms. Pereira, for your interesting presentation. Yeah. Now the floor is open for the questions. Yes. Any questions for Ms. Pereira?
Yes, Ms. Pereira, you did a nice presentation. Thank you so much for that first. And also I wanted to ask one question from you is that why did you only select the carbon dioxide and particulate matter itself? Because I know that there are some other significant pollutants, for example, NOxes. So was it because of your objectives of the study, or did you conduct your research based on a request given by a government body or something like that? Is that the reason?
According to previous research articles, I show that I conduct this research in Kandy area. In Kandy area, there can be seen in high pollution in PM and carbon dioxide related air pollution. Therefore, I conduct this research based on those air pollutant, and also I measured some kind of other kind of air particles and air pollutants, but I couldn't see any kind of huge differences in those air pollutants regarding their optimum levels in those candy area. Therefore, I got PM and CO2 only for the consideration.
Okay, that makes sense actually. Okay, thank you. And also, so what is your next step in your research? Like, are you going, so you have few recommendations. So how are you going to incorporate your recommendations with the government body or any other responsible stakeholder to make some necessary management actions?
According to that, this research result can be used to policy making when we want to develop a new city or in tropical country. We can establish this kind of 100 to and 100 to 50 vegetation barrier length to meet optimal levels in when we want to building establishment far from the road.
I think, yeah, your research will be very, very important for the people who are working in the road development authority or any other road projects, because they are dealing with the environmental impacts, those like pollutant generation, etc. So your findings will be very much important or significant to those people actually. Yeah, thank you so much for your presentation.
Thank you very much.
Okay, thank you, Vishan. And Miss Pereira, yeah, you are talking about new cities. What about existing cities? Can't we apply this method for existing cities?
In existing cities, we can also use this method by establishing new plant barriers, such kind of
have some space there along roads.
Yes, madam, there can be show that.
Miss, I have a question, Miss Pereira. Thank you for your interesting presentation. So, few research findings of some studies have said sometimes vegetation barriers can also have the negative effects in terms of pollutions. So, do you encounter any that kind of challenges?
Yes, madam. I face some kind of issue because when I collecting data, it is with the flowering season. It is when I collecting in first set of data, it is in low level of air pollutants in PM, and when I considering in flowering season, there can be seen in some kind of effect in PM in flowering season due to pollen effect, and when we want to reduce that pollen effect, it is mainly so in the fruit plantation. I found that when we want to reduce
pollen effect, we can induce the coniferous plantation with the finest plantation. We can reduce those effect by the dispersion and diffusion effect of pinus plants. Therefore, we can mitigate PM related air pollution due to pollen effect by that.
How about the deposition effect?
It is mainly when considering that phenomena, there can be seen some kind of effect in the leaf configuration or leaf shape in a needle shape. Therefore, it can be used to deposition speed reduction by the upwind barrier configuration effect.
So all these are considered in your research findings, or you have?
Yes, with the previous research findings and as well as in my findings.
Okay, thank you. Thank you very much.
Thank you very much.
Okay, thank you, Ms. Pereira. Now let's move to next presentation, the last presentation for the morning session. Effect of textile fiber reinforcement on drying, shrinkage, and mechanical properties of in situ cast mud concrete lot bearing walls. And the authors are W.S. Vikramaratne, F.R. Aros, Aryu Halwatura, and Jiva Jayasinghe. Okay, Mr. Vikramaratne, yes, you can start your presentation.
Have a nice day, all of you. Today I'm here to present our research presentation, Effects of Textile Fiber Reinforcement on Drying Shrinkage and Mechanical Properties of In situ cast mud concrete load bearing walls. Let's go through this presentation. This is the content of our presentation. Let's see the introduction part. Evolution of houses started from caves to modern houses. Early people, they lived in the caves and under the big trees. But the development of houses changed with the development of societies. We use different types of building materials to construct houses. They are cement, sand, reinforcement bars, and tiles like that. Increase the consumption of materials and resources for the construction industry create negative impacts on the environment. We know the production of cement produces large amount of carbon dioxide into the atmosphere. The carbon dioxide contribute to the global warming. In Sri Lanka, most of the land near to the rivers are degraded due to the sand mining. Now world is still struggling to find some solution for the increasing demand in housing with the growing population. Therefore, we should pay our attention to the sustainable building material. That material should be economically affordable and environmentally friendly. The researchers have identified soil as an ideal construction material before the advent of cement and concrete. Then they have pointed out the novel concept to the construction industry called mud concrete. If we use mud concrete technology to construct a house, we can obtain a lot of advantages. Then there are two types of mud concrete. The first one is mud concrete block. The other one is mud concrete load bearing walls. Then we consider the composition of mud concrete. We use 45% of gravel, 50% of sand, and 5% of fine. Then we use 10% of cement to construct the mud concrete. Then we use 20% of water to mix the mud concrete. The problem is statement. Most of the building materials are porous in their structure. They expand when they absorb the moisture. They shrink when they dry. Due to the shrinkage of mud concrete wall, shrinkage crack will appear and represent the outer wall of the mud concrete. It causes to collapse of constructed buildings. Finally, it may lead to decrease in the trend for this novel concept. This figure shows appear cracks in the mud concrete wall. Objectives of this study are investigate horizontal and vertical drying shrinkage, investigate optimum curing period, and identify the best fiber material and optimum fiber percentage to mitigate drying shrinkage of textile fiber reinforced in situ cast mud concrete load bearing walls. This is the methodology which I followed. I will explain one by one. According to the literature, I found textile fibers can be used as reinforced material. They are polypropylene, coconut fiber, bamboo fiber, polyester, and cotton. Then water correction. Water correction is identification of optimum water percentage to mix fiber added mud concrete. In earlier, I said 20% of water is enough to mix the mud concrete. But in our research, we added some amount of fiber to the mixture. Therefore, 20% of water is not enough to mix mud concrete well. Then we keep gravel, sand, fine, cement and fiber percentage as constant. Then we vary water percentage from 30% to 50%. After getting data, we prepare a line chart, the compressive strength against to the moisture content. You can see there is a negative correlation between strength and the moisture content. According to this line chart, you can see highest strength was recorded to the 30% of moisture containing mud concrete. Then we identify the optimum water percentage for the textile fiber reinforced mud concrete is 30%. Then we prepare our sample using fine, sand, gravel and cement according to the suitable mix proportion. Firstly, we use polyester fiber. Then secondly, we use polypropylene fiber. We use fiber from 2% to 10% from total dry soil weight. Then we prepare 3 non-reinforced samples were prepared and kept as control. After preparing mud concrete specimens, we kept for casting by covering wet gunny bags. The curing period is 28 days. This figure shows curing process. After completing 20 days of curing period, we measure the compressive strength and we measure the drying shrinkage of the prepared mud concrete specimens by using following equation. After getting data, we prepare a bar chart to represent the compressive strength of polyester fiber reinforced mud concrete. The bar chart is prepared the strength against to the fiber content. You can see when we increase in fiber content, the strength also increasing. Then we recorded the highest value is 4.33 newtons per square millimeter. That value was recorded the 10% of fiber containing mud concrete. Then we put the lowest value that is 3.2. Then we did the t-test. The result is H0 is rejected. That means there is a significant difference of compressive strength between non-fiber reinforced and fiber reinforced mud concrete. Then we prepare another bar chart to represent the polypropylene fiber reinforced mud concrete. When we consider the compressive strength of polypropylene fiber reinforced mud concrete, you can see when we are increasing fiber content, the strength also increasing. Then again, the highest value was recorded from the 10% of polypropylene fiber reinforced mud concrete. Then according to the literatures, they mention the standard requirements for the soil-based materials are 1 for the wet compressive strength and 2 for the dry compressive strength. In our research, our lowest value is exceed the standard requirement mentioned in the literatures. And also I found the coconut fiber reinforced mud concrete research, they mention their lowest value is 4.75. But in our research, our highest value is lower than their lowest value. When we consider the compressive strength, there are 3 types of bond in the mud concrete specimens. They are soil-soil bond, soil fiber bond, and fiber-fiber bond. The applied compressive load is tolerated by these 3 types of bond. Further, we increase in the fiber content, the compressive strength will achieve the optimum compressive strength. However, further we increase in fiber content, it will cause to decrease in compressive strength. Because when we are increasing fiber content, the amount of soil fiber bond increases. Then it leads to decrease the amount of soil bond. The soil bond is the major bond type effect to the compressive strength. Then I measure the horizontal shrinkage of polyester and polypropylene fiber reinforced mud concrete. I got data over the 28 days. Then I prepare a line chart to represent the shrinkage strength. Then I prepare a line chart. You can see the shrinkage strength against the number of days. In this chart, you can see when we are increasing fiber content, the shrinkage strength also reducing. When we did the t-test, the result is H0 is rejected. That means there is a significant difference of horizontal shrinkage between non-fiber reinforced and 10% of polyester fiber reinforced mud concrete. Then again, I prepare another line chart to represent the polypropylene fiber reinforced mud concrete. then you can see the range between control and the fiber contained in mud concrete specimen. Then again we did the t-test. The result is H naught is rejected. That means there is a significant difference of horizontal shrinkage between non-fiber reinforced and 10% of polypropylene fiber reinforced mud concrete. According to the literatures, they mention the major reason for the shrinkage of the building materials are the loss of moisture from its fine pores result in shrinkage. The drying shrinkage will introduce tensile stresses which, if they exceed the tensile strength of the clay, will cause the wall to crack. When we are adding fiber, fiber closes the pores in mud concrete and it causes to reduce the loss of moisture from the specimen. Therefore, it leads to reducing the shrinkage. The rate at which the material loses moisture depends on some factors. They are shelter, environmental conditions, and material characteristics. The level of shrinkage depends on soil grading, clay content, initial and final moisture content, and also rate of drying. Our conclusions are increasing proper curing procedure can reduce the shrinkage strength. To minimize the shrinkage crack, 14 days proper curing period is recommended. Polypropylene fiber is better than polyester fiber in reducing the drying shrinkage. Addition of textile fiber increases the compressive strength of mud concrete and also recorded highest strength is 4.33 newtons per square millimeters for 10% of polyester fiber. These are our references. My presentation is over. Thank you for listening.
Okay, thank you very much, Mr. Vikramaratne, for your interesting presentation. Now the floor is open for the questions.
Madam, I have a question.
Yeah, sure.
So very well presented, Mr. Vikramaratne. So what is the way forward of your study? What are you going to do?
Madam, nowadays in Sri Lanka, due to the inflation, most of the building materials are the price of the building materials are very increasing. Also the labor cost. Now we are introducing this technology to apply to the construction industry. So if we can overcome those problems, we can establish the houses by using mud concrete technology.
So now this product is ready to be commercialized, or
under the testing, madam, because of then this is the another one problem, and some problems are have occurred in this technology. This under the research, madam, they are testing.
So you were testing on those biological parameters, those things?
No, madam, I only test the strength and the shrinkage.
So it is a part of ongoing research, right?
Yes, madam, yes.
Okay, thank you.
Thank you, Kirtana. Actually, how you apply textile material there? Mr. Vikramaratne, that means powdered, or what's that particle size and
no. I get the textile material. Then there is a equipment called shredder. I put that material into the shredder. The materials was shredded by using this machine. Then I apply to the mixture. Then mix with manual mixing in the mud concrete mixture.
Yeah. That means there are no particles. That means parts.
No, madam. In that machine generate the minimum particle size used to the mud concrete.
Okay.
Madam, I also have a question. Yeah. Yes, madam. So how about the cost for the materials?
Okay, sorry.
Sorry, sir.
How about the cost? Cost of material per square meter?
Yeah, I also asking the same question.
Sir, didn't calculate the cost, but I spend money to bring the one cement.
Maybe when you commercialize, if you are it's better to commercialize. I mean, if you are hoping to commercialize it, then it's better to consider about the cost also, right? Okay.
Yes, sir.
What is the source of your fiber? Where you have obtained?
In the garment sector, I collect those fiber from the garments.
So now they are not reusing, right?
Yes, they remove that parts, then I collect that type of fiber.
Do you test tested actually what is the texture of the mud clay texture?
Sir, I use the red clay soil sample.
What is the sand percentage? That means texture. What
Yes, sir. I
texture
use
of the
45% gravel and 50% of sand and 5% of fine.
no organic matter. Okay.
And how about, did you did you make any compare between the conventional type and this mud concrete, the weight comparison? Did you do any?
No, sir, no, I didn't compare, but then we consider the strength with the only concrete cubes and mud concrete cubes. The concrete cubes are very stronger than the mud concrete cubes due to the high percentage of cement applied in the concrete cubes.
Ah, okay. Okay, thank you for the nice
Thank you very
presentation.
Yeah,
much.
Mr. Vikramaratne, I have one question. Sorry, madam.
Time is up anyway. Okay, your one question.
Okay, so how about the continuity of getting raw materials for your production?
Sir, I found the soil from the University of Moratuwa to conduct research. Then I need the fiber, so I get the fiber from the garment sector. These are the raw materials I found.
Okay, so always you have to link those institutes, right? For example, the garments to get the raw materials. Okay.
Yes.
Yeah, because if you are planning for the commercialization, you have to focus on those factors as well. Okay, thank you so much, Mr. Vikramaratne.
Okay, thank you, sir.
Okay, thank you, Mr. Vikramaratne, for your interesting presentation. And now the time is actually morning session is over now. So let's have a break for the lunch. Half an hour is enough. Kirtana, yeah.
Madam, usually
The
we
floor is
need
for
1 hour. So we will break at 12:30 now and see you at 1:30 p.m. You can use the same link that you have used previously to log in.
Yeah, Miss Kirtana, in the schedule, it is going to start 1 p.m. That 12:20 we have to finish and 1 p.m. we have to start it in the schedule. You know?
It's okay, and let's be flexible, and maybe student need some time.
1 hour?
Okay, madam, shall we give them 1 hour? Around 40 minutes, let's say.
minutes means we will start this one now 12:30.
1:10.
1:15.
1:10.
Yeah, around 1:15.
All right. Okay. Sorry. Yeah. Thank you. Hello.
Yes, madam.
Hello. Yeah, shall we start now?
Yes, madam. You can.
Okay, madam.
Yeah, we'll see Praneeth. Is Praneeth there?
Yes, madam. Thank you.
Yes, madam.
Okay. Okay. All right. Okay. So, good afternoon, dear students and all my colleagues. We'll start now our second part of our session today, evening session. The first presentation for the evening session is evaluation is continuous aerobic reactor under different OLR for the treatment of leachate generation from MSW composting, an experimental study by EAK Senadilankara, S. Vijayatungan, PD Pindenia. Now, I think Mr. Senadilankara is going to present the findings. Yeah.
Good morning, all of you. Today I'm going to present my final research presentation. The topic is evaluation of continuous endobic reactor under different organic chlorine rates for the treatment of leachate generation from unsaturated bed composting as experimental study. Let's move my presentation. These are the outline. First introduction in Keralpiti waste management park, degradable municipal solid waste convert to composting. Daily load 150 metric ton. Observed leachate in reference. Observed leachate production varying from 2 to 14 cubic meters per day throughout the year. The compost leachate is a liquid byproduct of compost that contain carbon, nitrogen, phosphorus, potassium, and trace elements. The raw compost leachate is an environmental problem. There is a many method to leachate treatment such as aerobic biological treatment such as aerated lagoons and activated sludge. Anaerobic biological treatment such as anaerobic lagoons and reactors. Physiological treatment such as air stripping, pH adjustment, chemical precipitation, oxidation, and reduction. In our experiment, we were treated raw compost leachate by anaerobic digestion. In the problem statement, large-scale raw compost leachate is an environmental problem in Keralpiti waste management park. Raw compost leachate barely affect to the aquatic plants and the aquatic animals. Requirement of proper way to treat this fresh leachate and reduce the bad effect of fresh leachate is a current challenge. These are the objectives of my study. Determine the suitability of compost leachate to produce biogas, fabricate anaerobic continuous reactor to treat raw compost leachate. Finally, evaluate the efficiency of biogas production under different organic chlorine rates. This is a flow chart of materials and methodology. The first sketch of continuous type anaerobic reactor. You can see pictures of my continuous type anaerobic reactor. This is a feed intake. I use 200 liters plastic barrel to plastic barrel as anaerobic reactor. This is an outlet of effluent and gas outlet. I fill with this barrel from 2 out of 3 height of barrel bottom to top. The procedure: startup phase. 8 kilograms of charge cow dung measure and mix with the 8 kilograms of water in mixing tank 1:1 ratio. And barrel was filled with 100 liters of cow dung slurry and 33 liters of raw leachate. The ratio 3:1. Final volume was 133 liters. Before filling the cow dung water, Mr. CV with a porous diameter of 2 millimeter. Finally, the system was correctly sealed to avoid an aerobic condition and to ensure the gas removal. Keep the digester for 10 days without any input. The operation of biogas well. After 10 days of time, continuous procedure start. Initial organic chlorine rate 1.6 grams CO liter per day. After the constant value of biogas volume, then change the organic chlorine rate. There are 3 cycles in organic chlorine rates. In first cycle, organic chlorine rates 1.4665 grams CO liter per day, HRT 10 days. Second cycle, organic chlorine rates 1.4355 grams CO liter per day, HRT 8 days. HRT means hydraulic retention time. Third cycle, organic chlorine rate 1.11 54 grams COD liter per day, HRT 7 days. So then the next, the checked parameters. In here, I mentioned the check parameter and the check instrument and the frequency, temperature, pH, electrical conductivity, total dissolved solid, salinity, dissolved oxygen, total solid, nitrogen, phosphate, phosphorus, and carbon oxygen demand. So in the statistical analysis, first we check is there any significant difference in these parameters. I use Kuskal one-way ANOVA to this. And after, if they are significant or not, check the output. The parameters are significant or not, as well as the finally check is there any significant difference before and after endopic digestion. I use Wilcoxon sign rank test to test that. So then the then we move to the resultant discussion part. First, properties of leachate. You can see average pH value, average BOD value, average COD value, total solid, total fixed solid, total dissolved solids, total suspended solid, total volatile solid, fixed dissolved solids, volatile dissolved solid, fixed suspended solid, volatile suspended solid. As well as the compost leachate, I measured the properties of carbon slurry. As previously mentioned, this is solid content of the cow dung slurry, total solid, total fixed solid, likewise the solid content. So then when it comes to the properties of leachate, predetermined were suitable for the biogas production in anaerobic digestion because of the raw compost leachate BOD to COD was 0.312. For the good biodegradability of any wastewater, a minimum BOD to COD ratio 0.3 to 4 is considered to be ideal. So then let's move one by one parameters. Temperature, you can see the temperature comparison of influent and the effluent. So there is no significant difference in influent and effluent temperature in 3 cycles. So when we compare, there is no significant difference in influent and effluent temperature also. So in here, influent and the effluent temperature at the optimum range, you can see the range in mesophilic range 22 to 40 Celsius. Mesophilic range. So then let's move the pH. pH influent of pH of influent and pH of effluent. You can see there is a significant difference between influent pH in 3 cycles, but there is no significant difference between effluent pH in 3 cycles. And actually, there is a significant difference between influent and effluent pH. But influent pH varies from time to time because of the evaporation, and some point in the graph, the effluent pH goes high more than the effluent. So because of the during the last stage of anaerobic digestion named metagenesis, gases such as methane, hydrogen sulfide, ammonia used to get produced. All these gases are basic in nature, and when dissolves in the semi-detracted target leachate, it converts to the same alkaline in nature. Thus, the pH level may increase up to the 10 based on the quantity of this gas yielding during anaerobic dark fermentation. So then we move to the dissolved oxygen. There is no significant difference between effluent dissolved oxygen, but there is significant difference between effluent dissolved oxygen. And also there is no significant difference between effluent and the effluent values. It means there in anaerobic digestion, DO does not change. This is a comparison of dissolved oxygen. There is then we move to the electrical conductivity. There is no significant difference between influent and effluent electrical conductivity values in 3 cycles. And as well as there is significant difference between influent and effluent electrical conductivity values. You can see the electrical conductivity comparison. Actually, when it comes to electrical conductivity and salinity measure the water ability to conduct electricity. In this experiment, there is significant difference between before and the after electrical conductivity and salinity of the compost leachate. High electrical conductivity and means high level of dissolved oxygen, dissolved solids and salt. The reactor contain complex microbial communities that break down the waste and produce the resultant biogas and digestate. Researchers have already demonstrated that the increase in the conductivity of effluent can be directly, this is a special point, the conductivity of effluent can be directly correlated to ammonium nitrogen release during the digestion. So then let's move salinity. There is a significant difference in influent salinity values as well as the effluent salinity values in 3 different cycles. There is a significant difference between influent and effluent salinity values. a comparison. This is a comparison of salinity. So let's move the TDS as well as electrical conductivity and salinity. TDS act like in same manner. So then there is no significant difference in influent and influent TDS values, but there is a significant difference in effluent TDS value. So finally, but there is a significant difference between influent and effluent TDS values as well as EC and salinity. In here, electrical conductivity, salinity, total dissolved solids are the same type of parameters. Then the total dissolved solids are the amount of organic and inorganic material, such as metals, minerals, salts. Then particle, the dissolved solids in particle, volume of water, that parameter has affected the anaerobic digestion. COD, when it comes to COD, there is a significant difference in influent COD values and effluent COD values in 3 different cycles. Also, there is a significant difference between influent and COD values. This is a comparison of COD in COD out and the COD in the all 3 cycles. So, explain, an anaerobic digester convert organic materials into the biogas and digest it in the absence of oxygen. And it means it have decreased effluent COD value, but some point it decreased. Say special point. With the hydrolysis step of the organic particulate material, more soluble substrate is released and convert the acid before methane and other gas production. That hydrolysis step could generate more soluble fraction that is high COD value and that may high COD respond. So then phosphate phosphorus, you can see the phosphate phosphorus comparison in influent and effluent. So when it comes to the phosphate phosphorus, there is significant difference in influent phosphate phosphorus and effluent phosphate phosphorus in 3 cycles. And also there is no significant difference between influent and effluent phosphate phosphorus values. The special point, during the anaerobic digestion, hydrolysis takes place there, and organic matter is mainly converted into methane with both ammonia and phosphate are not consumed during the process. That's why there is no significant difference between influent and effluent phosphate value. So the nitrate nitrogen, there is no significant difference in influent nitrate nitrogen and effluent nitrate nitrogen. But there is a significant difference between influent and effluent nitrate nitrogen values. You can see the comparison of nitrate nitrogen in influent and effluent. The study clearly demonstrated that the nitrate and nitrate were denitrified during the subsequent digestion process, resulting in the formation of the nitrogen gas in the reference. And methane production was not completely, as a special point, methane production was not completely stopped even in the nitrate-rich environment. So then we move to the total solids. There is no significant difference in influent and effluent total solids values in 3 different cycles, but there is significant difference between influent and effluent total solids values. This is a comparison of total solids. Then the total solids contain in a certain amount of material is usually used to the used as the material unit to indicate the biogas. Biogas producing rate of the material. It means decrease the total solids. Total solids, special point, total solids contain influence anaerobic digestion performance. Digested acidification at high total solids content causes inhibition of metagenesis, and that hydrolysis rate constantly slight decrease with the increase in of total solids. So then this is then we move to the biogas volume. There is significant difference between biogas volume of 3 different cycles. You can see cycle 1, cycle 2, cycle 3 biogas volume. So explain based on the methane only, the maximum theoretical production is 0.35 liters methane per gram of COD at 0 Celsius. But in my reactor, average biogas production 170 milliliter. According to the my organic loading rates, this is the organic loading rate, theoretical biogas volume per day, biogas volume in the experimental study. This is a comparison. Actually, theoretical values are not practical in the well. This is a comparison of efficiency of 3 cycles, cycle 1, cycle 2, removal percentage of salinity, electrical conductivity, TDS, COD, nitrate, total solids, and the total biogas volume. This is a Central Environment Authority water quality standards. In the category C, shall be water suitable for the aquatic life. So then the total solids COD, BOD, pH, DO include these parameters. Only COD and the BOD values are higher than the standard values for the water suitable for the aquatic life. but pH values and DO values are in a standard range. So then finally, conclusion. According to the properties, the leachate is suitable for the anaerobic digestion. Fabricated continuous anaerobic reactor could use to run this experimental study in the good manner. The organic matter, COD, and the nitrate content in leachate significantly were reduced during the anaerobic digestion process. When organic loading rate is increased, the biogas production rate is reduced. The biogas production efficiency is very low in this reactor. The effluent after biogas digestion is not environmentally safe according to the Central Environmental Authority guideline. According to the result of this study, even though reactor operated well, its performance is very low and the reactor cannot be recommended to use without modification for the efficiency of improvement. So these are references. So thank you.
Okay, thank you very much, Mr. Senadi Lankara. You have obtained very detailed presentation. You have obtained all 15 minutes for that one. Okay, one question is allowed for the discussion. Any questions for Mr. Senadi Lankara?
Madam?
Yeah. Yes, Anupa.
I can't hear you, madam.
Sorry, can't you hear me?
Now okay, madam.
Yeah.
Mr. Senadi Lankara, can you hear me?
Yes, sir.
So what are the challenges that you faced during your project?
There are some challenges, sir. Before I come to this site, there is no any biogas unit or any experiment conducting here, and I don't know is there any capability of produce biogas from this leachate. The condition of leachate and it means biodegradability. That's why this is an experimental study. That's the main challenge. So.
Okay. Since we have one question, so I will hand over to the.
Yeah, actually the time is already passed from him. Okay, then thank you very much, Mr. Senadi Lankara. Actually, very detailed presentation. That's good. Anyway, but the time is given for you only 10 minutes.
Okay, madam. Thank you, madam. Thank you, madam.
Let's move to the next presentation. Experimental investigation on the manufacture of pavement block using industrial chemical sludge by WSW Vikramasinghe, GKP John, RU Halwatra, GY Jayasinghe, and NPK Semananda. Okay, floor is open for Miss Vikramasinghe.
Good morning, everyone. My research topic is investigation potential utilization of industrial chemicals like for pavement box manufacture. These are my outlines. And Deep Product PLC is a company that manufactures laser-based rubber gloves. The chemicals are generated from the form of machine and in depression handling containers contain heavy metal and needs to be recycled. In general, effluent generated from the textile industry contain high concentration of the heavy metals which originate from the color pigment of textile dyes, and utilization of the sludge as a replacement of sludge fine materials or clay. The manufacture of block, bricks, and building materials has been extensively studied in various lectures. These units are proposed to be manufactured of party replacement of cements. And significant of the research use the chemical side for paving blocks manufacture help to diverse sludge from landfills and generate benefits. And additionally, by the using sludge as party replacement of cement, the environmental impacts associated with the extraction and manufacture of the cement can be minimized. These scopes are only chemicals that is used to manufacture these paving cement blocks. This features examines whether it is possible to create paving blocks, and toxicity leachate procedure is not performed on the chemical paving blocks to check whether heavy metals will leach out of the paving blocks. And problem is test ones. This is the biggest byproduct generated in the wastewater treatment plants, and the final disposal is a serious problem as it involves the environmental issues, handling and transport costs, and sludge treatment represents the 50% of the capital and operation cost of the wastewater treatment plant. Disposal of the sludge is a major problem because it is a contaminant groundwater to solid. And the product PLC was found containing the chemicals lead, chromium, zinc, calcium oxide, mercury, and arsenic. These chemical sludge should not be disposed in the waste landfill due to high concentration of the zinc used in the sludge for compost manufacturing is not feasible. And at the end of the gloves manufacturing process, the equipments are cleaned using chemicals and water. The wastewater regenerated from the cleaning process generated as sludge that is rich in organic and inorganic chemical compounds. Therefore, this sludge cannot be released to the environment. At present, they are incinerating the sludge. The method is not suitable as it is very costly and very harmful to the environment. And sludge is semi-slurry slurry that can be produced from the range industrial process and from the wastewater treatment and on-site sanitation system. The several wastewater treatment techniques are used to textile fluid treatment and the psychometry methods and biochemical methods and biochemicals method. Amount of the sludge generated per week can average 5.5 tons to 6 tons of the sludge is generated in 2 months, accordingly between 0.08 to 0.05 tons sludge generated in the week. And cost of the current sludge management biologically sludge compared production is also provided as a 25,000 according to it. Total cost of the all current sludge management according to the this this following activities 1 million 1 million for one manage to all the sludge and technical aspects. The four types sludge generated in this plant: biological sludge, chemical sludge, and depression using sludge and CFC sludge. And objectives of the this research to determine the appropriate mix ratio of the cement, sludge, and aggregate for the manufacturers of the paving blocks. Determine the physical and chemical properties of the sludge cement paste and determine the physical chemical properties of the paving blocks manufactured with party replacement of cement and determine the optimum water content level, improve the strength of the paving cement blocks. These are my flowchart, methodology flowchart. First, identification problem and the next the review and the chemical sludge and site visit and finally analysis. And next, obtain the sludge sample and sludge pre-treatment. And next, literally review on the manufacturer contracts and material using chemical sludge and determination of the properties of the sludge cement sample and casting paving blocks and determination of the physical and chemical properties. And finally, determination of optimum water content from the strength of the paving blocks. And first one is site visit and preliminary analysis. PLCD product company was visited to require the volume of the chemical sludge was collected according to the standard procedure and all the required information about the process of sludge disease, the types of sludge, content of the sludge, and cost of sludge and present environment and damage of the sludge. And this picture shows the location of the product PLC at Brahmanagama and stakeholders are the product PLC, housing cement factories and the peoples and legislative background is Central Environment Authority and National Environment Act. This picture shows the chemical site process management. They have 6 small tanks and collect the sludge and sludge remains after the water drains. These are such pre-treatment. Sludge was dried in hot oven at 100 Celsius for 24 hours to remove water from the sludge, and then sludge was grounded and clean rice steel plate and was used to the substitute for cement. And this picture shows the grinding method they used to sludge grinded. And this picture shows the 0.1 millimeter sieve and sieve the sludge in this sieves. And this picture shows the cement mixer, cement sludge paste mixed by this cement mixer. Sludge mix ratio 10%, 15%, 20%, 25%, and 30%. Use the cement 400 gallon and water to 15% percentage. This picture shows the VCAT equipment they used to measure the consistency to samples. And this picture shows the after the final setting science this concrete and cement samples. This picture shows the preparation of paving blocks as cement, sand, chipstone 1 to 2 to 4 ratios and submerged paving blocks and testing method strength of 7 days and 28 days. This table shows the recommended grades of the paving blocks by different categories, but we select only the grade 15 and traffic category only. Strength class in the 15 and 15 millimeter for square and traffic category non-traffic and examples for application landscaping, public garden and parks. This picture shows the sample length 200 millimeter, width 98 millimeter, and 57 millimeter. And this table shows the results and discussion. First row shows the consistency. The best consistency range is the 5 to 7 millimeter. The consistency at all samples used here has between 5 to 7 millimeter. Therefore, all samples were suitable for testing. And another row shows the initial and final setting signs. Initial and final setting signs of the other sample was longer than the control samples, but it's not a problem for their testing. And this table shows the compression strength after the 28 days. What had 25% cement replaced by sludge, and according to the stand, selected 10% sample sludge sample only. These are expected value 15 millimeter Newton millimeter square, and they add to water 15%, but they can, according to this stand, they select 10% and 50%, 15% sludge add to the sample. These are expected value for 50% Newton millimeter square. And this graph shows the compression strength increase over time. This grade 15 line of the expected value. 10% and 15% are used to strength. And this table shows the strength changes according to the percentage of water. This first bar shows the 15% water content, and second bar shows the 25% water content, and blue bar shows the content control sample, and green bar shows the 10% water sample, and orange color shows the 15% sample. Factor strength after the 28 days, water add to 25%. According to the grade, selected 10% sample only. The standard, according to the standard, STMS is 37 third point load standard. And this table shows the fractal strength after 28 days. Water add to 15% cement replaced by sludge. According to the stand, select 10% and 15% samples. This show fractal strength shows the this used to this calculation, and this shows the calculation summary. And water absorption capacity after 28 days. These values of the water absorption test should be reported to nearest 0.05%. According to the standard, this used this calculation. And drying sinkage capacity. This table shows the drying sinkage capacity. The value of the drying sinkage should be reported on the nearest 0.01%. According to the stand, is used to this calculation. And conclusion, the standard consistency of the whole sample has been between 5 millimeter to 7 millimeter. Therefore, sludge mortar first used to research, and this research was able to process successfully. And since in this research, the sample with 10% sludge and shows the highest compression and pressure strength. Furthermore, when the water content was reduced to 25% to 15%, the compression strength of the paving blocks increased the 60.68 Newton millimeter per square to 70.53 Newton millimeter square. According to this results of this research, paving blocks can be manufactured by the replacing 10% of the cement with the sludge at the water content 15%. Furthermore, the pavement blocks manufactured by replacing the encrusted aggregate with the sludge provide the lower compression strength to the pavement blocks manufactured with the partial replacement of cement with sludge. However, further testing must be carried out the accurate compression. And these are my reference. And thank you.
Okay, thank you very much, Mr. Vikramasinghe. Very fast presentation for very fast presentation. Now floor is open for the discussion. Yes. Any questions for Mr. Vikramasinghe?
Yeah, madam.
Yes, Anupa.
Yeah, Mr. Vikrama Singha.
Yes, sir.
So, what are your future plans about this research? Because I mean, you got good results here. So, what
Yeah.
you are going to do with this result?
I think, sir, in the production of cement, a lot of damage done into the environment, and this can be used to as the substitute to
Substitute
for
to
cement.
cement.
Yes.
So you mean cement? This one is stronger than cement? No?
Same, partial replacement of cement to this sludge, 10% and 15% good for good results.
So did you check with the strength for cement also for that block?
Sorry, sir.
Did you do any strength test for the cement block also?
Yes, sir.
Okay, so the comparison is similar.
Similar, sir. Small quantity change and no problem.
So that means lower cost for the sludge block.
Yeah. Yes.
Okay. Thank you.
Thank you, sir.
Okay.
Any more questions for Mr. Vikramasinghe? Okay, Mr. Vikramasinghe, I have a question, small clarification actually, rather than a question. Now these sludges, these are chemical sludge. Now you are using for payments. And please let me know whether these chemicals available in this sludge, are they washable?
Madam, first I said that the leachate procedure will be further investigated.
So it will be an environmental health hazard then?
Yeah, some, but I think leachate procedure cannot be seen in short period. It is an ongoing research.
Okay. Okay, then thank you very much.
Thank you.
Okay, then let's move to next presentation. Life cycle assessment of sugar industry in Sri Lanka, reference to energy production and utilization. Authors are PH USD Silva, Tilanka Aryawansha, WB MAC Bandara, GY Jaising, and Kazuhito Sakai. Mr. Silva, floor is yours. Miss Silva, yes.
Have a nice day. I'm PHUSD Silva. Today I'm going to present my research presentation, Life Cycle Assessment of Sugar Industry in Sri Lanka, reference to energy production and utilization. These are outlines, and let's see introduction. Sugarcane is a renewable biomass energy source that is considered the most important energy crop. Sugarcane industry mainly produces sugar, and also it produces bagasse, molasses, meal mud, and boiled ash as a byproduct. Sri Lanka's annual total sugar requirement is around 55,000 tons and locally produced only 8%. Currently, there are 4 functioning sugar mills in Sri Lanka. There are Palavatta, Savanagala, Hingurana, and Nakimale. This is our problem statement. Sri Lanka's efficiency in energy production and utilization of the sugarcane industry is still far behind the potential level. The main reason for that, a comprehensive database for the sugar industry energy sector has not yet been fully established, and no proper information about what areas need to be improved on the energy side, and sugar industry byproducts energy utilization is far below the potential level. Our main objective is to analyze the energy production and utilization in the sugar production according to the life cycle assessment standard method. And also, we compare the conventional and modern sugar industry in Sri Lanka and identify opportunities for improving the energy performance of the system and give suggestions on the operation and development of the sugar production process. In here, we use life cycle assessment method. Our goal is to investigate the life cycle of energy production and utilization from sugarcane cultivation to sugar production in the sugar production factories in Sri Lanka. Our functional unit is 1 ton of raw sugar manufactured from the factory process. This figure shows our system boundaries, sugarcane cultivation to factory gate level. We have conducted life cycle inventory analysis. Life cycle inventory data was mainly obtained by means of in situ data collection, databases, scientific and technological literature, and equipment operational manual. In here we use semaphore sector and also we use eco-win-win database and active footprint database. The impact assessment was performed using software semaphore 9.3 version. In here we use cumulative energy demand method and IPCC 2021 GTP for 100 years method. This is result and discussion. Cumulative energy demand for Savanagala is 4,540 megajoules per ton of sugarcane. For Etimale, 7,080 megajoules per ton of sugarcane. Both of sugar industry, sugarcane cultivation and harvesting phase consume more energy than other phases. When we compare with other results, the Indonesian sugar industry cumulative energy demand is higher than our results because they use coal for their factory processes. In Brazil, they have low cumulative energy demand than our results because in that factory include the credits related to electricity and the gas surpluses. IPCC 2021 global temperature potential for 100 years. For Savanagala, 67.8 kilogram carbon dioxide equivalent and Atimale 47 kilogram carbon dioxide equivalent. Both of sugar industry, sugarcane cultivation and harvesting phase contribute most for the greenhouse gas emissions than other phases. When we compare with other results, Mexico sugar industry, sugarcane growing and harvesting stage has the most harmful environmental impact, and in Iranian sugar industry, show irrigation step is the most harmful environmental impact. This slide, first figure shows impact assessment single score cumulative energy for sugar production for Etimale sugar industry and Savanagala sugar industry. Second figure shows impact assessment characterization. In here we consider fossil, biogenic, carbon dioxide uptake and land transformation. This is our conclusion. In here, Etimale sugar industry has more cumulative energy demand than Savanagala, but Etimale needs more land to prepare to manufacture 1 ton of sugar. On the other hand, Etimale is more mechanized than Savanagala. Therefore, due to both reasons, Etimale shows more energy demand compared to Savanagala. Also, Etimale has generated excess electricity, therefore this is an advantage even though Etimale has more energy demand. The issue could be overcome by enhancing the cane yield, optimization of machine use, and increasing machine use efficiency to reduce energy demand. These are references and thank you.
Okay, thank you very much, Ms. De Silva. I think you have finished it before 10 minutes even. Okay, now the floor is open for the questions. Questions for Ms. De Silva?
Yes, madam.
Yeah, are there any questions from our audience? Hello? I think they also can't believe because you have finished it very soon.
Yes,
Yeah.
madam. So what was the yeah? So what was your research finding in the end? Like you made the comparison between Etimale and Savanagala? Is it like?
Yes, I have compared Etimale and Savanagala sugar industry about cumulative energy demand and environmental impact.
Okay. Okay. Thank you.
Thank you, sir.
And are you going to give this message to those sugar industries?
Yes, madam.
What you are going to say?
Nowadays, I am planning about that. Actually, Etimale sugar industry has more cumulative energy demand, but when you consider about some points, the Etimale is more Etimale is very better than Savanagala. Nowadays, we are planning to inform to that sugar industries.
Which in Savanagala, you mean in energy wise? You are planning to improve. What did you say?
Savanagala sugar industry has a low mechanized than Etimale. So I think Savanagala need to introduce new technology to their factory, especially in cogeneration process.
Okay. Okay, thank you. Are there any questions for Ms. De Silva? It seems no more questions. So thank you very much, Ms. De Silva. Okay, and let's move to next presentation. That's about recommendation on source emission air quality standard for sanitary landfill sites in Sri Lanka. Sanitary landfill sites in Sri Lanka by DHU Lakshani, G.Y. Jaisingh and RNR Jayaratne. Ms. Lakshani, yes, you can start the presentation.
Have a nice day, all of you. I'm DH Ushara Lakshani. I conducted my final year research on recommendations of source emission air quality standards for central landfill sites in Sri Lanka. Let's see the outlines. Introduction, then problem statement, objectives of the study, materials and methodology, results and discussion, conclusions, and finally references. Let's take a quick introduction. In the world, especially in developing countries, solid waste is a major problem. In Sri Lanka, especially in urban areas, municipal solid waste management practices are not sufficient. 3,500 tons to 600 tons of waste is produced per day in our country, and the per capita waste generation amount is 0.64 kilograms per day. Among the provinces of our country, Western Province is the highest producer of waste. So it is very much important to take necessary actions to solid waste management. So, as a solution to this problem, central landfill site was built in Kindwala. However, landfills contribute to emissions of various landfill gases such as nitrogen dioxide, ammonia, nitrogen oxide, methane, carbon dioxide, sulfur dioxide. So, under the problem statement, we identified in Sri Lanka, we have a few number of air quality standards. But, however, these air quality standards not cover landfill-oriented gas emissions. So, it's very much important to introduce such kind of source emission standards for landfill gases to reduce the emissions from those sites. So, under the objectives of my research study, my main objective was to suggest recommendations of source emission air quality standards for landfill gases in the central landfill sites in Sri Lanka. And the second one was to find means of gases and particulate matter concentrations in the site. And third one was to find temporal variations of particulate matter concentrations in the site throughout the day. And finally, I expected to find spatial variations of methane gas emissions in the cells of the landfill. Under materials and methodology, I conducted a systematic review on two research results of Google Scholar. They were solid waste dump sites, atmospheric pollution, and the second one was landfill emissions and gas and air quality. So altogether, I selected 863 research papers from the Google Scholar. And the methodology of the systematic review, first I identified the keywords, then I selected articles from Google Scholar under exclusion and inclusion criteria. Then I removed duplicate articles, summary papers, review papers, books. Then I arranged those articles in a Microsoft Excel, and finally I did a comparative analysis. And so finally I selected 15 research papers. I selected articles which was published in English, and I selected articles published between 2000 to 2022, and I took only original research papers. I measured methane concentrations from the soil surface of each sampling points on the cells, on the surface of the cells. Then after that, I analyzed with flame ionization detector determined gases concentrations in between 3 different time periods. Height was 140 centimeters from the Earth's surface. For that, I used sensor-based air quality monitoring device, and I measured some climatological parameters. And results, I actually calculated the volume of the cells. Cell tree has the highest volume, and the cell 4 has the lowest volume of the waste. So, and I collected data some data regarding waste, such as daily landfilling waste and total waste quantity up in 2022, and composition was non-degradable, non-recyclable polythene, plastic, rubber, glass, fiber. 71% of waste was brought the Shisaba around the Western province, and the rest of the waste was brought from industries. Under my main objective, I suggested source emission air quality standards for Central Lanka sites in Sri Lanka. We have ambient air quality standards for carbon monoxide,
Something happened to her.
Concentrations of the gases emissions. I suggest 1000 ppm per 8 hours for CH4 concentrations as the air quality standards according to the NIOSH recommended exposure limit, and I suggested 1000 ppm for carbon dioxide according to ASHRAE and OSHA standards. According to the NIOSH recommended exposure limit, I suggested 5 ppm averaged over an 8-hour day for ammonia, and for hydrogen sulfide, I suggested 10 ppm per 10 minutes per period and 20 ppm not to be exceeded at any time according to the OSHA and NIOSH standards. Because I took those kinds of standards because of most of research papers, they have taken those standards for their comparing purposes. That why I used them, and all the parameters except PM2.5 concentrations have not and most of vehicles come to the site in between. Actually, when considering the particle matter concentrations, there are actually a significant difference between PM2.5 concentrations throughout the day, and particle matter 10 concentrations show the same results like PM2.5. Observed a spatial variation of CH4 concentrations in the landfill site. So finally, I can conclude that there was not temporal variation of PM2.5 and PM10 in the landfill site. There was a spatial variation of CH4 concentrations in the site according to cells. According to the suggested source emission air quality standards, all the measured gases emissions were below the recommended values except PM2.5 concentrations. And finally, the suggested source emission air quality standards for central landfill sites should be further developed. So these are the references that I used, that I followed. So with that, it is the end of my presentation. So thank you very much.
Thank you very much, Ms. Lakshani, for your important presentation. Any questions for Ms. Lakshani?
Yes, I have one question. Ms. Lakshani, yes, during your analysis, have you used any protocols to screen out the articles, for example, like using Prisma or something?
Actually, not, sir. When comparing, actually, I first I selected 864 research papers, and from that, I selected only 15 research papers. According to that, I arranged Excel sheet with mentioning important ideas. Then, according to that, I identified most of time in Sri Lanka. Actually, we have not ambient air quality standards for particle matter concentration, those kinds of emissions. Actually, we have not. For that, from OSHA, ASHRA, and OSHA standards, I used from, because of most of research papers they have used for their comparing purposes. That's why I used.
Okay. So, what were the most important inclusive and exclusive criteria that you used for selection of your papers? Did you show anything in your slides?
Yes, sir.
Okay, thank you, Gushan. Any other questions for Ms. Lakshani?
So, yes, madam. So, what would be your suggestion to improve the air quality according to your research?
Actually, according to my experiments, I found only PM2.5 concentrations have exceeded this suggested value. So actually, because most of time, many number of vehicles come to unload the unload waste, and because of that, those particle matter concentrations and sometimes dust particles, because of that, these particle matter concentrations have exceeded. So we have taken necessary actions to reduce these concentrations.
Okay. Okay, thank you.
Okay, thank you very much, Ms. Lakshani, for the presentation. Okay, let's move to next presentation. Assessment of water quality in selected habitats in Kidalkale wetlands. AMNS Attanayaka and S. Vijayatunga. Ms. Attanayaka, floor is yours.
Good day to you all. My research study is regarding assessment of water quality in selected habitats of Kerala wetland under supervision of Professor S. Vijayatunga. The outline of today's presentation is like this. And what is the most significant natural resources in the ecosystem serving a vital role in both drinking and economic sectors? The availability and quality of surface and groundwaters have changed dramatically during the last century, owing primarily to urbanization and industrialization. Wetlands are nature-based solutions in terms of climate change mitigation and adaptation strategies, sustainable use of natural resources, supporting biodiversity, securing ecosystem services, and so on. Hydrological value of a wetland is admiring due to the services offered to the society, including water for drinking, agriculture, livestock farming, and moreover, water purification, water quality improvement, silt deposition, and contaminant trapping. According to the Ramsar Convention, wetlands are areas of marsh, fen, peatland or water, whether natural or artificial, permanent or temporary, with water that is static or flowing, fresh, brackish or salt, including areas of marine water, which the depth of which at low tide doesn't exceed 6 meters. According to the Ramsar Convention, there are three main categories of wetlands in Sri Lanka, namely inland natural freshwater wetlands, marine and saltwater wetlands, man-made wetlands, and among these, Kelakali wetland is an urban freshwater wetland. When considering the problem statement of the research study, water quality is affected by different causes, and water of this wetland is used by the villagers around the wetland for agriculture and also drinking purpose, and also for recreational activities, specifically fishing. They don't consider about the water quality, and the improper use of water resources cause accumulation of chemical components in human bodies, crops, livestock, and so on. Ultimately, severe health ailments will be occurred, and in case of proper cleaning and purification of water, have to aware on the water quality parameters of the water resource. Primary objective of my study is to assess the water quality of the Kerala wetland through assessing physical, chemical, and biological water quality parameters, and my specific objectives are to assess water quality using weighted arithmetic water quality index, and also to assess water quality using biological monitoring working party score system. When coming to the materials and methodology, the study area is the wetland part, western part of the Kirlakale wetland, which is located in Mathura, southern province, Sri Lanka. It is linked to the livelihoods of local people as an urban freshwater wetland, and it is located 3 kilometers away from the Mathura city. These are the 12 sampling points which I have selected purposely from the western part of the Kirlakale wetland. Under physical and chemical water quality assessment, I have gone with the weighted arithmetic water quality index. These are the equations I have used to calculate the weighted arithmetic water quality index. This table shows the weighted arithmetic water quality index values and rating of water quality, and also the grading of water quality. Water temperature, pH, turbidity, electric conductivity, biological oxygen demand, BOD5, dissolved oxygen, total suspended solids, nitrate, nitrogen, and ammonium nitrogen were considered under physical and chemical water quality assessment. 12 locations were selected from the western part of the wetland, and one water quality parameter was replicated 3 times for a sample. Water samples were collected 3 times in 30-day interval, and water samples were stored in pre-cleaned high-density polyethylene bottles, which were washed out by sample water thrice. pH values are recorded using the pH meter, electric conductivity by the electric conductivity meter, dissolved oxygen by the dissolved oxygen meter, turbidity by the turbidity meter, nitrate nitrogen and ammonium nitrogen by the UV spectrophotometer, total suspended solids by the gravimetric method, biological oxygen demand by the titrometric testing method, water temperature by the mercury thermometer. When considering the determination of biological water quality by observing aquatic macroinvertebrates, I have used the Biological Monitoring Working Party score system. This BMWP score system needs taxonomic identification of macroinvertebrates to family level. Macroinvertebrates were collected from 12 locations in the wetland and related families were identified. Each family owns a related score. The cumulative score for the wetland is the BMWP score of the western part of the Killakale wetland. This table shows the BMWP scores and related water quality categories and a brief description of water quality categories. Data were analyzed by using the Minitab 17 statistical package and also with the aid of Microsoft Excel software. This table shows the mean values of water quality parameters during the study period, March, April and May. When coming to the results and discussion, these graphs shows the variation in water quality parameters in March, April and May. First, we talk about the temperature. Water temperature. Water temperature is an important water quality parameter of a wetland since many physical, chemical, biological water quality parameters are directly affected by the water temperature. Average water temperature values of the wetland were ranged within 30 to 33 Celsius with a mean value of 31 Celsius. The highest average water temperature value was recorded from 9th sampling point in April and lowest from the first sampling point in March. When coming to pH, pH is a measure of acidity or alkalinity in water. Since chemicals in the water can change the pH of the water, and mean value of the wetland water pH is about 7.1 and it ranged within 6.9 to 7.2. And the highest average pH value was recorded from the 11th sampling point in April and the lowest from the 6th sampling point in March. Electrical conductivity is a measurement of a material's capacity to pass an electrical current. The average EC value is ranged within 0.44 to 1 microsiemens per centimeter and with mean value of 0.55 microsiemens per centimeter, and the highest average EC value was recorded from the 7th sampling point in April and lowest from the 11th sampling point in May. When coming to dissolved oxygen, the DO test quantifies the amount of oxygen necessary for life to exist in the water, and average DO values were ranged within 0.81 to 4.2 with the mean value of 2.7 milligram per liter. And the highest average DO value was recorded from the 11th sampling point in April and the lowest from the 6th sampling point in March. The amount of oxygen needed by the microorganisms to decompose the organic matter in the water is known as the biological oxygen demand. This measurement is made over 5 days at 20 Celsius degrees. Average BOD values are ranged within 4.89 to 18.51 milligram per liter and mean value of 9.81 milligram per liter. The highest from the 10th sampling point in April and the lowest from the 6th sampling point in March. Turbidity is a measurement used to assess a liquid's relative clarity. The turbidity values are ranged within 3.06 to 30 NTU with a mean value of 10.48 NTU during the study period, and 7th sampling point was recorded as the location where having highest average turbidity in April and lowest from the first sampling point in May. Total suspended solids is the amount of fine particle matter that is still suspended in water. Average total suspended solid values of the wetland were ranged within 0.13 to 14 milligram per liter and with mean value of 2.3 milligram per liter. And the highest value is from the 9th sampling point in April and the lowest from the 4th sampling point in May. Nitrate is produced by the natural processes like plant decay, the fertilizers, animal waste, sewage system discharge are more resources of nitrate. Average nitrate nitrogen values were ranged within 0.03 to 0.3 milligram per liter with mean value of 0.17 milligram per liter. The highest average value from the 10th sampling point in April and the lowest from the 11th sampling point in March. Ammonium can come from domestic, industrial, or agricultural pollution, from fertilizers, organic matter, or fecal matter. Average ammonium nitrogen values are ranged within 0.01 to 0.02 milligram per liter with a mean value of 0.016 milligram per liter. Fourth sampling point was recorded as the location where having highest average ammonium nitrogen value in May and lowest from the 12th sampling point in March. These are the data collection for the calculation of weighted arithmetic water quality index. It is resulted as 97.22. These are the observed macroinvertebrates and related BMWP score for the western part of the Killa-Kali wetland. The cumulative BMWP score is 63. In conclusion, the weighted arithmetic water quality index for the western part of the Killa-Kali wetland is 99.22. Based on the weighted arithmetic water quality index, water of the western part of the Killa-Kali wetland is not suitable for drinking without prior treatment, and the BMWP score for the western part of the Killa-Kali wetland is 63. The water quality is acceptable for biological parameters and the water is clean and slightly impacted. Water of the western part of the Killa-Kali wetland is suitable for irrigation if dissolved oxygen can be increased, and the water of the western part of the Killa-Kali wetland is suitable for bathing, recreational activities, especially fishing, if it is possible to increase the dissolved oxygen levels. There is no significant difference between parameters like electric conductivity, dissolved oxygen, biological oxygen demand, total suspended solids, turbidity, and ammonium nitrogen within the study period. And there is a significant difference between pH values in April and March and also May and March. There is a significant difference in nitrate nitrogen values between months of March, April, and May. Based on the study, it can be concluded that the water in the western part of the Killa-Kali wetland is not much polluted yet. However, more attention should be paid to avoid or minimize the anthropogenic activities that are responsible for the pollution of the wetland. These are my references, and thank you.
Okay, thank you, Miss Attanayaka. I think you also consume, 13 minutes. Anyway, the time is only for one question. Questions for Miss Attanayaka?
Okay, madam, I will ask one. So I would like to know that in your study that I saw there are for electrical conductivity and then the turbidity. In seventh sample, there is a kind of a very increasement, higher increasement comparing to the others. What is the reason for that? Do you know?
Yes, sir. The highest average electric conductivity was recorded from the muddy wetland bed. The muddy water contains different sizes of solid particles and impurities. So ions are attached with the soil particles. Therefore, the highest average electric conductivity was there, and lower from the inflow water stream due to less amount of iron in the water due to less amount of pollution.
Okay. Thank you for the nice presentation.
Thank you, sir.
Okay, madam.
Thank you for your nice presentation. So what are the biological parameters that you have considered?
Aquatic macroinvertebrates, madam.
So you didn't measure the microbial related stuff?
Not microbial, madam. It can be visible from the naked eye, like crustaceans and likewise aquatic macroinvertebrates.
Okay.
Okay, thank you very much, Miss Satanayak and Kirana both. And let's move to next presentation. Life cycle analysis and life cycle cost assessment of organic versus conventional sugarcane cultivation in Sri Lanka. Authors KKT Madhushani, Tilanka Arivansha Kumarage, UWLM Kumarasiri, and CP Rupasinha. Okay, floor is yours, Miss Madhushani.
Have a nice day, all of you. I wish to present my final year research under comparative life cycle assessment and life cycle cost analysis of the organic versus conventional sugarcane cultivation in Sri Lanka. This is my content of the research. I give brief introduction about sugarcane. Sugarcane is the perennial crop which uses to mainly manufacture sugar and jaggery. There are four byproducts. There are spent wash, filter mud bagasse, and molasses. Molasses is used to prepare ethyl alcohol. Another usage are organic fertilizer preparation. Main factories are located in Sevanagala, Palwatta, Atimale, and Hingurana. Currently cultivated 35,000 acres. Local sugar production in 2020 was about 9.9% and imported sugar about 90.1%. In my research is fall down life cycle assessment and life cycle cost analysis. Life cycle assessment is the tool to evaluate environmental effect throughout agricultural production system between organic and conventional farming of sugarcane. And life cycle cost analysis evaluate the total cost of relevant time period of sugarcane cultivation that focus on least agricultural inputs for higher productivity production. Problem statement of my research is life cycle cost and life cycle assessment should be applicable for Sri Lanka, but there is no comprehensive comparison of life cycle assessment and life cycle cost analysis for environmental impact, and no enough evidence for impact potential for environment. Objective of the study to investigate the most suitable farming system which cause least environmental impact between organic and conventional sugarcane production through life cycle assessment, and to select most cost-effective sugarcane farming system using life cycle cost analysis. Finally, implement the recommendation, minimize the relevant environmental issues, and awareness the people. Materials and methodology of my research. My methodology consists with four steps. They are goal and scope analysis, life cycle inventory analysis, impact assessment, and fourth one is interpretation. First step is the goal and scope definition. In goal definition, they identify purpose of study as an internal and external to benchmark and comparison for future development. Secondly, identify intended audience for respond environmental issues, reduce environmental barriers, and implement actions. Finally, how the results are used, process design for improvement. In scope definitions, identify functional unit of my research. It is a 1 ton of sugar cane yield. Scope definition analyzed the system boundary. My system boundary was cradle to gate as assessment of life cycle from resource extraction of sugar cane to factory gate before which is transported to the consumer. Second step is the inventory analysis. In here, I designed process flow chart from land preparation to sugarcane harvesting with their all inputs and outputs. As inputs, fuels, electricity, machinery, fertilizer, pesticides, water, land, manpower, and infrastructures. Output as the emissions of soil, air, and water. Inventory data were collected at the Sugarcane Research Institute in Udawalawe and Lanka Sugar Company Devanagar unit and Lanka Sugar Company Atimala unit. Third step is the impact effect assessment. In here, identify significance of potential environmental impact of sugarcane production among organic and conventional farming system. Impact assessment is based on life cycle inventory results. Impact assessment consists of 4 steps. First one is categorization. Firstly, I selected categories from climate change to abiotic depletion from global to local. Second step is characterization. In here, modeling life cycle inventory result to the impact categories using science-based convention factors in both farming systems. Third step is the normalization. In here, compare all the impact categories with the same unit to get an idea about the magnitude of the impact of each category. So, comparison of cultivation system with normalized results. Final step is weighting. In here, weigh the significance of the environmental impact. Fourth step is the interpretation. In here, identify the significant environmental issues for recommendation and obtain conclusions for environment. Another procedure is my research is life cycle cost analysis. In here, life cycle cost of inputs with all investment and maintenance cost of sugarcane, energy, equipment, fertilizers, pesticides, herbicides, water of organic and conventional sugarcane farming. My system boundary was the cradle to gate from land preparation to harvesting, and my functional unit is the 1 ton of sugarcane. Data analysis was conducted with the SIMA-Pro version 8.4.0 and output of the figures was analyzed by the Microsoft Excel application software. Life cycle impact assessment method used in this study is the recipe hierarchies perspective version 1.12 with midpoint indicators. You can see result and discussions. In here, inventory analysis. Based on inventory data, energy usage is higher in organic sugarcane cultivation rather than conventional sugarcane cultivation. And there was huge fertilizer amount differentiation in organic sugarcane cultivation rather than conventional sugarcane cultivation. Organic sugarcane cultivation need 14 ton of sugar of organic fertilizers per hectare. But conventional sugarcane need urea, triple superphosphate and muriate of potash as total amount of synthetic fertilizer amount is 600 kg per hectare. When we consider the output data, there are significant amount are in organic sugarcane cultivation of sulfur dioxide, nitrogen and phosphorus leachate and carbon dioxide rather than conventional sugarcane cultivation. When we consider impact assessment, the realized characterization result, it can be shown in which highest contributed significantly climate change, terrestrial acidification, freshwater eutrophication, photochemical oxidation, and particulate matter formulation are highest contributor to environmental impact in organic sugarcane cultivation rather than conventional sugarcane cultivation. Another environmental impact are quite varied in both farming systems. You can see the climate change, terrestrial acidification, freshwater eutrophication, photochemical oxidation, and particulate matter formation are highest contributor in organic sugarcane cultivation. Let's see normalization result. The summation of normalization result of conventional sugarcane cultivation and organic sugarcane cultivation were 0.335 and 81.948 respectively. Therefore, total impact of organic sugarcane cultivation is 245 times higher than the conventional sugarcane cultivation. You can see this figure. Higher effect can be observed on freshwater eutrophication by organic sugarcane cultivation. When we analyze the process contribution analysis of conventional sugarcane cultivation, that effect is split into the 6 inputs categories that are cultivation process, urea, triple superphosphate, muriate of potash, diesel, and electricity. Cultivation process is the significant to climate change, terrestrial acidification, freshwater eutrophication, marine eutrophication, photochemical oxidation, and particulate matter formation. Finally, water depletion. You can see cultivation process and electricity are the main contributor in conventional sugarcane cultivation for their environmental impact. When we consider organic sugarcane cultivation, there are 18 impact categories is graphically depicted. That effect is split into the 4 main input categories. They are cultivation process, organic fertilizers, diesel, and electricity. The impact categories are mainly influenced by cultivation process and electricity. You can see cultivation process and electricity are main contributors to their environmental impact. Another procedure is my research is life cycle cost analysis. Here, cost of cultivation could be seen that be lower by 23.82% in conventional sugarcane cultivation than in organic sugarcane cultivation. Highest cost in organic sugar cultivation could be cost to fertilizers, manual weeding, and other usage such as maintenance and prevention activities. When we consider about the productivity of 1 ton of sugarcane yield, when we considering productivity of organic sugarcane cultivation, realize 5.2% lower yield than conventional sugarcane cultivation. And profit was higher by 51.2% from conventional sugarcane cultivation rather than organic sugarcane cultivation. You can clearly identify productivity and profitability of conventional sugarcane cultivation are higher than organic sugarcane farming as 5.2% and 43.64% respectively. Interpretation. The total impact of organic sugarcane cultivation is 245 times higher than conventional sugarcane cultivation. Higher effect can be observed on freshwater eutrophication and terrestrial acidification by organic sugarcane cultivation. And finally, carbon dioxide emission of conventional sugarcane cultivation is lower rather than organic sugarcane cultivation, as over 10 Conclusion conclusion of my research is less environmental impact and higher productivity farming system is conventional farming system. As a recommendation to minimize fertilizer application using precision agricultural technically. These are my references which I was used for the listening.
Okay, thank you very much, Miss Madhushani. You also got almost your total time for discussion also. Okay, we will allow you to have one question. I will allow audience to have one question for Miss Madhushani. Only one question. You don't have question for Miss Madhushani?
Miss Madhushani.
Yes, sir.
So, did you encounter any limiting factors for your study or challenging factors in your study? So what are those? Did you understand my question?
Yes, sir. When I started my research, but organic cultivation was planted that time. So I got data from Sugarcane Research Institute, organic for the organic farming data.
Okay, that's all I have to ask from you. Thank you.
Okay, thank you very much, Kushan and Miss Nadishani. Okay, let's move to next presentation. Effect of organic fertilizer application of post-harvest quality on amble banana by A.M.L. Atapattu, K.H. Saranand and C.P. Rupasinghe. Miss Atapattu, I think, Mr. Atapattu, yes. Floor is open for you now.
Good evening to all. Today I am here to present my research topic on effect of organic fertilizer application on post-harvest quality of ample banana. This is the outlines of my presentation. And first of all, I would like to discuss introduction part. Banana is one of the most important crops grown in Sri Lanka. Approximately 60,000 of hectares of lands are under banana cultivation, and it's about 54% of the total fruit cultivation lands. Nearly 100,000 of farmers are engaged in banana cultivation. Organic agriculture is a production system that supports the soil health, ecosystem, and people. And there are several advantages of organic fertilizers over chemical fertilizers. Farmers have a positive outlook towards organic farming. Fruit quality can be measured by using quantitatively and qualitatively. Vitamin C content, total soluble solids, total tritable acidity can be measured as quantitatively, and sensory attributes like aroma, taste, texture, and overall acceptability can be measured as qualitatively. This is the problem statement. Most of farmers are engaged their cultivation by using organic fertilizers and agrochemicals. When chemical fertilizers are introduced into the field, the yield of their plantation has been increased, so that the majority of farmers are alert to use of chemical fertilizers and agrochemicals. And some research studies have been done to investigate the health symptoms related to agrochemicals used in farmers and laborers. And currently farmers converted their cultivation by from inorganic to organic due to the higher prices and the shortage of fertilizers and agrochemicals within the market. Objectives of the study. Main objective is to investigate the effects of organic fertilizer application on post-harvest quality of ample banana, and there are other three objectives: to assess the sensory properties of ample banana as affected by organic fertilizer application, and to find out the occurrence of post-harvest diseases in response to organic fertilizer application, and to compare the physicochemical yield characteristics, shelf life, and health benefits of ample banana treated with organic fertilizer with conventional application of fertilizer. Let's move on to the materials and methodology part. Two blocks of ample banana planted with a spacing 3 meter by 3 meter with having 30 plants per each block. While planting 2 kg of organic manure was mixed with soil-only organic block. For the conventional planting, Department of Agriculture recommendation of chemical fertilizer was used based on the recommendation, and all plants of uniform size were planted, and the fertilizer application, except fertilizer application, all the other agronomic practices were done equally, and all bunches were harvested at 85 days after maturity. And this table shows the fertilizer recommendation for banana cultivation and the chemical composition of used inorganic fertilizers. And let's move to the laboratory analytical procedure. Total nitrogen was measured by Kejal method through the processes of digestion, distillation, and titration. Available phosphorus was measured by Olsen method by using spectrophotometer, and the exchangeable potassium was measured by flame photometric method. This table shows the soil analysis of the experimental site and the chemical analysis of the used compost. And this is the data collection procedure. Total soluble solids was measured by handheld refractometer, and the total titratable acidity was measured by using titration by using 0.1 sodium hydroxide and phenyl used as an indicator. pH was measured by pH meter at room temperature, and peel color development and flesh color development was measured by colorimeter. Antioxidant activity was measured by the DPPH, free radical scavenging activity. And the shelf life was measured by visual inspection, and sensor evaluation was done by untrained 35 judges. Disease severity was measured by disease index based on the slightly modified 0 to 5 scale without inoculation of pathogen. And the yield parameters like middle hand weight of middle finger of middle hand, and the length of middle finger of middle hand, and number of fingers of middle hand were selected for the study. And the statistical analysis. Quantitative experimental results were subjected to analysis of 2 sample t-test, and the qualitative sensory results were analyzed by using Wilcoxon rank sum non-parametric test. Let's move to the results and discussion part. Physiochemical properties like total soluble solids, pH, and total titratable acidity were significantly affected by type of fertilizer application. In total soluble solids, inorganically treated banana was significantly higher than the organic banana, and these results could be due to the availability of nutrients like nitrogen and phosphorus, and also hydrolysis of starch into the sugar during ripening process. In total titratable acidity, in inorganic banana was significantly higher than the organically treated banana, and this could be due to the high acid content of inorganic chemical fertilizer. When we consider about the pH value, organic banana was higher pH, significantly higher pH than the inorganic banana. This may be due to the total titratable acidity increases causing a drop in the pH. According to the results obtained for L, A, P, and Q value for the peel color development and flesh color development, significantly affected by fertilizer application. And the disease severity of anthracnose and shelf life were significantly affected by fertilizer application. In disease severity, inorganically treated banana was significantly higher disease severity rate than the organic banana. In usually green banana peel has higher antifungal compounds, and they react to some pathogens. But the amount of antifungal compounds gradually decrease when the production of ethylene during ripening process. Ethylene inhibits the action of antifungal compounds. And organically treated banana was significantly higher shelf life than the inorganic banana. And when we consider about the antioxidant activity, the results, according to the results obtained for IC50 DPPH free radical scavenging activity, was significantly affected by type of fertilizer application. Great antioxidant activity of the sample is indicated by a low IC50, so that the organically treated banana was significantly higher antioxidant activity than the inorganic banana. Yield characteristics like middle hand weight, number of fingers per middle hand, and the finger weight and finger length of middle finger of middle hand were significantly affected by fertilizer application. And these results could be due to the chemical fertilizers, as they are more readily available to the plants immediately after the application. And when we consider about the sensory properties, organically treated banana showed the best results on all sensory attributes compared to the inorganic banana, and the taste and overall acceptance was significantly higher mean rank score in organic banana compared to the inorganic banana. And this is the conclusion part. Application of inorganic fertilizer greatly influenced yield characteristics compared to the organic fertilizer, and banana grown with organic fertilizer significantly affected total gradable acidity pH in mature banana fruits. Inorganic fertilizer had significant effects on total soluble solids, and the results clearly showed that the supply of nutrients through inorganic fertilizer significantly affected the disease severity of anthracnose and shelf life. And organically and inorganic grown banana fruits had similar peel color and flesh color development during ripening. And the organic banana had the higher antioxidant activity as determined by the DPP free radical scavenging activity, help to the reduce the risk of variety of chronic diseases. And the results of sensory evaluation showed that the organic fertilizer had influenced the taste and overall acceptability. And these are the references. And that brings us to end of my presentation. And thanks to all for your collaboration. Thank you.
Thank you very much, Mr. Atapattu. Yeah, thank you very much. And yeah, paper is open for the discussion now. Any questions for Mr. Atapattu? It seems no questions. Okay, Mr. Atapattu. Then now you have you got some findings there. After doing your research, you got some findings there. With that findings, what are you going to do in future? That means you are going to promote organic banana cultivation, or and if do so, what are the challenges the farmers has to face?
Actually, madam, when we consider about the yield characteristics, inorganic banana was significantly higher than the organic banana. But the post-harvest quality, organic banana was significantly higher than the inorganic banana. So that this research, this study could be ongoing with different fertilizers such as integrated nutrient management, and this also manner.
Yeah. Yes. I think you have signal problem.
Hello.
Hello. Yes. Now I can hear you. Yeah.
So that this research can be doing with integrated nutrient management practices. And some studies have been done to different fertilizer mixtures such as 75% inorganic and 25% organic, and farmyard manner, and different fertilizers. Studies showed that the best result in the nutrient management practices.
Okay. Right. Then you told me about the quality. What are the quality parameters you have measured? Yeah.
Total soluble solids, total titratable acidity, antioxidant activity.
Okay. Then how they change with inorganic and organic? What do you think? I think you may have some literature for that. Why
Yes.
with organic the quality is good, and why with inorganic quality is not good?
When we consider about the disease severity rate in organic banana peel has higher antifungal compound than the inorganic banana.
The reason for that, did you find any reason for that? Why it has antifungal?
Because of inorganic banana has high acid concentration, and this acid concentration destroys the amount of antifungal compounds, and these antifungal compounds directly acts on pathogens. And during the ripening process, the banana will produce ethylene, and ethylene inhibits the action of antifungal compounds. The disease rate increase.
Okay, thank you very much. Okay, thank you for your presentation and things. Now let's move to next presentation. Assessment of environmental impact by tea production in low country, Sri Lanka, through carbon footprint calculation by AWDR Kalpani, CM Nawar and N. Peleni. Yeah, Kalpani. Yes.
Good morning, all of you. I am Dashini Ruvantika Kalpani. The topic of my research study is assessment of environmental impact by black tea production of low country Sri Lanka through carbon footprint calculation. The outlines of this presentation are introduction, problem statement, the objectives of the study, materials and methodology, resultant discussion, conclusions and references. In Sri Lanka, around 4% of the country's land area is covered in tea plantations amounting to nearly 203,000 hectares. The tea industry is one of the major agro-industrial sectors in Sri Lanka. Economically, the tea industry generates 65% of export agriculture revenue and contributes approximately 4.2% of island's GDP. Then the Sri Lanka is the country produces tea throughout the year, and the total tea production is about 340 million kilograms per annum. Sri Lanka is ranked in the third place of world black tea export market, but number one orthodox black tea supplies to the world market with its quality and tasty. Here you can see the tea production by elevation in Sri Lanka. These figures shows that energy use in the different stage of tea life cycle in 3 tea growing regions in Sri Lanka. According to that, you can see the highest energy usage in production stage and the consumption. Black tea production depends on different factors including transport, burning fuel woods, energy use and fertilizers application, which contributed to releasing nitrous oxide, carbon dioxide and methane to the atmosphere. Taking actions on carbon may produce new commercialization points for products and services. It will assist to sell products with high environmental standards. Several research studies have been conducted to assess the life cycle of tea process in Sri Lanka, but recommendations have not been based on the elevation and specified for an area. Therefore, LCA is an essential part in low country tea process as they are the highest black tea producers in the country. The objectives of this study are to identify key steps and energy use of the orthodox black tea production process in low country Sri Lanka, to carry out a life cycle inventory by covering all the stages in orthodox black tea manufacturing process in low country, to calculate carbon footprint in orthodox black tea production process in low country Sri Lanka, and also to assess the study result and propose proper countermeasures for reducing environmental impact and carbon emission in the orthodox black tea production of low country Sri Lanka. We selected 3 tea factories in low country as our study area. According to that, we selected Sicilian Tea Factory Tapassarakanda, New Vitanakanda Tea Factory, and Morapidia Tea Factory. The selection criteria of these factories are located in the elevation below 6,000 meters. Also, average annual rainfall 2,500 millimeter. Average annual temperature 27 centigrade. Annual average production more than 3 million kilogram per annum. Data were collected by visiting selected 3 tea producing factories. Also, data were collected from the factories is only for the processing stages. Then calculations were made for energy and greenhouse gas emissions at all stages of production. Achieving the first object of our research study, we identify steps of the factory process and energy use. We collected electricity bill details and production details, and also fuel use per 1 kilogram of made tea, and then biomass use per 1 kilogram of made tea. In this table, we can see energy consumption benchmarks for tea industry low country Sri Lanka. We will calculate the greenhouse gas emissions of factory process using these formulas. For all the data, 1 kilogram of made tea concerned as the functional unit. The highest specific energy consumption recorded by factory 1, 1.228 kilowatt hours per kilogram. The average specific energy consumption of low country tea industry is 0.957 kilowatt hours per kilogram. Here you can see the life cycle inventory of machine data and calculations of factory 1, then factory 2, and the factory 3. For electricity, the emission factor is 0.5422 kilogram carbon dioxide equivalent per kilowatt hours. Finally, average greenhouse gas emission for machine data is 8.686 kilogram carbon dioxide equivalent 1 kilogram of made tea. Then the total greenhouse gas emission for fuel usage is 9.194 kilogram carbon dioxide equivalent 1 kilogram of made tea, and also standard deviation is plus or minus 1.061. This figure shows that the variance of monthly electricity consumption of selected tea factories from 2018 to 2020. This graph shows the consumption of greenhouse gas emission for overall process inside the factory. The conclusions are the study assessed the environmental impact of orthodox black tea production process in low country Sri Lanka as 17.88 kilogram carbon dioxide equivalent per 1 kilogram of made tea. Then energy use is highest in a factory at the processing stage due to high energy requirement for fermenting process. Therefore, the study assessed the highest carbon footprint and highest environmental impact of the orthodox black tea production process have been given from the fermenting stage. Therefore, should be analyzed emission reduction technologies by black tea production such as renewable technologies and energy efficiency projects to land use change projects to mitigate carbon dioxide emission in the atmosphere used in low country black tea production. These are the references which I use in the research study. Thank you, all of you.
Okay, thank you very much, Ms. Kalpani, for your detailed presentation. Now the floor is open for the discussion. Any questions for Ms. Kalpani? Okay, Ms. Kalpani, now you got the value there for low country black tea production, carbon footprint value. Did you compare this value with the available literature? Whether it is the reduced value or increased value rather than the available literature? Ms. Kalpani?
Yes, madam. I'm here.
Yeah. Did you compare your value with the available literature values?
Yes, madam. I compare those three factory.
So, what did you find? Our values are higher or their values are higher? What did you find?
Our values are higher.
Our values are higher than which country? Which country values you compare them?
Mid country and up country.
Within Sri Lanka?
Yes, ma'am.
Okay. No any other international literature for that?
No.
Then you mean low country greenhouse gas emission is higher than mid country and up country greenhouse gas emissions by tea production, black tea production?
Yeah.
Sure. Any other questions for Ms. Kalpani? Okay.
Yeah, here only you selected about the factory values, or how about the field stuff?
Sorry, sir.
Yeah, how about this field? So what are the environmental impacts of tea cultivation and management and preventive measures for the impacts? Say now there are some environmental impacts there. So how you this habitat conservation, deforestation, soil erosion, destruction of biodiversity, how that footprint affect on this production?
Ozone layer depletion, soil erosion within
Normally,
using fertilizers.
Normally 30 kilograms of carbon dioxide equivalent per the kilogram of tea. Is it your values? What's your value? The carbon footprint of tea in black, in the low country? What is that value?
Total greenhouse gas emission
What is the value?
17.88.
Value?
17.88 kilogram carbon dioxide equivalent per 1 kilogram of made tea.
So did you check with these packaging, those materials?
No, sir. I assess
Only factory process. I get only machine there.
But your title says different, right? Assessment of environmental impact by black tea production in low country, Sri Lanka, through carbon footprint. No any factory or anything. Isn't it? So that is 17 is very low value, I think. Are you not confident to answer? Hello?
Hello, sir.
Yeah, well, in the factory stuff now, it is given a wrong interpretation, right? Now you have to think about from the word go when starting, as I mentioned, for the field scenarios and then this factory stuff and even the packaging stuff. Now when you are getting and pack and put it into the until the consumption. So sometimes consumption it also consume, isn't it? So you have to clearly mention your borderline and it will really should reflect on the title as well, I think. So you can do it in your future fine tuning. Okay, thank you.
Okay, so thank you.
Okay, thank you very much, Mr. Kalpani, and thank you, Professor Jayasinghe, for joining the discussion. And now shall we move to last presentation today. It's about challenges of converting existing commercial building into green building in Sri Lanka. DMMN Disanayaka, CP Rupasinghe, GGT Chaminda, and P. Disanayaka. So Mr. Disanayaka will present it. Praneeth?
Madam, she is not there.
She's not there?
I think she is not presented today, yes.
Then that was the last one, earlier one.
Yes, madam.
Sir, I am there. I will present online.
You, do you have presentation? Okay, okay.
Yes, sir.
Okay, you can share.
Could you give me 4 seconds, sir? 2 minutes.
Is this Nirmal?
Yes, sir. I have sent my video, sir. But I
Mr. Designer, can you share your screen and do the PowerPoint presentation if you can?
Okay, sir. I have to join in
computer.
Yes, sir.
Okay, so that will take some minutes, right?
Shall I present tomorrow, sir?
No, I can share. Please give me.
Okay, sir.
branch.
Have a nice day to everyone. I am Nirmal Disanayaka, Faculty of Agriculture, Engineering and Environmental Technology, University of Ruhuna. Today I am going to conduct my presentation on challenges of converting existing commercial buildings into green building in Sri Lanka, a case study based on 8 constraints tower buildings. Okay, this is my outline, and let's move into the introduction. After commercialization, rapidly developed construction industry with the result of this relatively increased environmental impacts also build lot of buildings use a huge contribution to environmental pollution because of their high environmental footprint in urban areas. It's time to follow green concept in urban areas especially. Most of commercial buildings are a leading contributor to global warming and the environmental impact by encouraging to emit greenhouse gases, dumping waste and consuming large quantities of water, energy and resources. Mm, a green building is a building that use less water, optimize energy efficiency, conserve natural resources, generate less waste, and provide healthier space for occupants. Problem statement. There are two ways to achieve a green buildings. One is newly construct as a green building from step by step, and other one is existing buildings convert into green buildings. So new generation new green buildings perform sustainability at every endeavor because they are inherently taking shape for sustainability in planning level. But the existing green buildings have not pre-decided plan, and there is only green strategies are applied to an existing building. Therefore, there is a precision of existing green buildings in the world, especially in Sri Lanka. It may be because of economical issues, technical issues, or awareness issues. There is no such a comprehensive study recognize what kind of challenges have to face when converting an existing building into green building in Sri Lanka. Issues are different from one building to another building. As an example, institutional hospital buildings, hotel buildings, government buildings, commercial buildings, factories, and etc. There is a high tendency to convert commercial buildings into green buildings, more profitable organization than other buildings. The commercial buildings are more profitable organizations than other buildings types. Commercial buildings use a lot of energy, water, resources, generate solid waste, wastewater around the year, large quantities, and emit greenhouse gases and directly effect for the heat island effect. It is more beneficial to convert existing commercial buildings into green buildings as an organization, as a, to the society and environment also. There is no such a comprehensive study have been carried out in Sri Lanka. Objectives of the study: investigate the various challenges, issues that have faced converting existing commercial building into green building in Sri Lanka. Evaluate the possibilities of converting two different types of commercial buildings into green buildings based on GBCSL rating system. Methodology. Firstly, building selection. I have selected 8 constraints commercial buildings in Colombo. Data collection. Firstly, studied GBCSL rating system for existing building and collected data through field surveys, interviews, and data records and literature reviews. Data analyzed and evaluate the building with green rating system. Finally, recommendations. I have selected the two buildings, left-hand corner, 8 Space Tower 1 building. This is more all 15 years plus older, and the right-hand side, 8 Space Tower 2 building, 10-year plus older. These are the criterias majorly in GBCSL rating system for existing buildings for management, sustainable site, water efficiency, energy and atmosphere, material and resources, indoor environmental quality, innovation and design process, and social and cultural awareness. According to GBCSL rating tool, rating given will be as follow as out of 100 points, 40 to 49 points, it will be set as a certified level, 50 to 59 silver, 60 to 69 gold rate, and more than 70 or above 70 is platinum rated. Let's move to the results and discussion. Firstly, I have conducted awareness questionnaire survey based on awareness of green building and sustainability practices. I have interviewed top management to have an idea about how about their awareness in the sustainability and green building concepts. Awareness of sustainability is and 66.7 of top management is well aware about sustainability and sustainability practices. 33.3% also somewhat aware about sustainability and sustainability practices. There is no person have heard or no idea. There is a problem, awareness of green building certification. 75 of top management not aware in green building certification. Only 25% of management have aware of some idea. Whether the already certified as a green building or not, that two buildings somehow given us answer of their as certified. It is wrong. The both buildings doesn't certified yet, and awareness of benefits and advantages. Most of the top management have a good idea about benefits of green building and sustainable practices. These are the reasons that they have shows reason for not certified as a green building: lack of awareness, initial cost, architectural disturbance, insufficient policies, human resource problem, time consuming, not consider building environment. Those are the main reasons. Let's see the green building evaluation. This is 8 constants tower 1 building. This have obtained 25.4 pre-evaluation and have calculated the maximum points that can be obtained by improving the building is 52 points. And these are the criteria that can improve the building 8 constants tower 1. And when we consider about 8 constants tower 2 building, it have obtained 31 points out of 100 marks, and it can reach 58 points with improving the building. With these are the criteria that can improve in 8 constants tower 2 building. And finally, the conclusion: challenges, various issues for converting existing buildings into green building. Most trouble in criteria 5.0 material and resources, 6.0 indoor environmental quality and 7.0 innovation and designing process. These criteria are very difficult to reach existing buildings. Those practices. 8 Conspens Tower 1 already achieved 25 points out of 100 points according to GBCSL rating system, and by improving green building criteria, additionally 26 points can be achieved, then 51 points out of 100, and 8 Conspens Tower 1 building can upgrade as a silver rated building. Tower 2 also achieved 31 points out of 100 points in pre-evaluation, and can develop 27 points by improving the building performance. Then it can achieve 58 points out of 100, and 8 Conspens Tower 2 can be updated as a zero rated building. These are my references, and thank you very much.
Okay, thank you very much, Mr. Disanayaka, for your presentation. Now the floor is open for the discussion. Any questions for Mr. Disanayaka?
Yes,
Nirmal, what's your
Yes,
profile of cases now? How many buildings did you select?
I have selected only 2 buildings.
So what are them?
8 Conspens, Tower 1 building and Tower 2.
So what are the commercial activities they are undertaking?
Mainly, they have transportation agencies. Then there are LPT plantation head office, and 8 Conspens hotels, and 8 Conspens other agricultural businesses head office. All are there, and there is a IT site also on in the upper level. That kind of commercial building.
And they don't have GBCSL rated, no, not
Yes.
rated, right?
Not yet.
So commercial. Okay, then what are these two cases? And you interview people, right?
Yes.
So what are their profiles? Who are they? How many members?
Chief operating executives, operating engineers, and
in these 2 buildings.
Yes.
So,
and the building maintenance chief engineer.
So when did these buildings put up? Recently?
One is before 2012, the New Year's building, the 8 Conspens Tower 2, and Tower 1 was before 2007.
Okay, now the major barriers. What are the major barriers on that?
Major
That
barriers
means, when implementing the GB practices.
Yes.
What are the barriers faced?
Major barriers are it is very difficult to these buildings are built for another 50-60 years, and we can't change architectural law, the building sketches to in green build. We can't disturb their architectural structure. So it is very difficult to change air ventilation systems and maintain, bring that the air condition, indoor air quality to that the required level, and we can't do structural changes in the building. It is very difficult.
And normally, now each case, now you have 2 cases. Now simply Now, you don't need much, in rocket science now, we know the
Yes.
lack of awareness and commitment. Sometimes there are lack of understanding of the professionals, lack of skilled laborers, and then, lack of funds sometimes may be there. And sometimes now the nature of the land, right, slopey land or whatever, and sometimes lack of proper management. Though those are the things, right, happening around when we are converting that into a normal building to some sort of other building as well. You don't need to be that green building.
Yes.
So what the final outcome? Now before doing this, these things we can identify, right?
Yes.
Now can you put these things now? This is special buildings. So how? So that is, I don't know, commercial or what. So what is this final outcome after this research? That means now after you are doing that, you are coming up with the conclusion or the generalization. The green building cannot be done. That kind of stuff I felt.
No, sir. We
You are
can.
discouraging. Then in this sense, you are discouraging the green aspect, isn't it?
No, sir. We can upgrade those two buildings into silver level easily, but within the discuss of the engineers, they have to lot of we can get easily in silver certification, but more than if we go to if we are trying to go more than silver, it is very difficult because the economic cost is very high when we trying to.
That means what I did get is, don't try to convert the existing building into green building. Very simple, right?
No, sir.
Yeah, why not now? You are
They can go until silver label. They can go until silver label. That
Yeah,
is
it is. We can reach silver level very easily, but we have to achieve
But
when.
with gold or platinum, you cannot, right?
Yes, sir. It is very difficult to.
Okay, got it. Your final recommendation. Thank you.
Okay, sir.
Okay, thank you very much. I think now the time is up already. Then, okay. Then
Thank you very much.
thank you all 18 fresh graduates for presenting here today under emerging trends in environmental technologies. Actually, there are altogether 18 research findings. All are, I think, your first research. Actually, all are more or less good. That means you all find good findings, and though there are some small drawbacks and things, but anyway, since this is your first research, you have done a great job. So I wish you to do more and more research in future, avoiding those drawbacks and some mistakes and everything in the precision way. So good luck, all of you. Right? Thank you very much for giving us lot of findings here with good research work. Thank you very much, students. Now I hand over this to Ms. Kirtana.
Thank you very much, madam. An event like this cannot happen overnight. The wheels start rolling months ago, and it requires bird's eye planning and wide networking of people to accomplish the intended objectives. Such people truly deserve a sincere appreciation. On behalf of the fraternity of the organizing committee, I am here to propose the vote of thanks. First of all, I would like to extend our most sincere gratitude to the keynote speaker of the session, Professor Alex Lechner, Associate Professor in Urban Design, Monash University, Indonesia, for accepting our invitation and delivering a very comprehensive presentation on the remote sense applications for ecosystem, biodiversity, and forest mapping. We would like to express our heartiest appreciation to Dr. BMS Jinendra, Coordinator URSAE 2022, for his dedication in organizing this event in a better way despite several challenges. Next, we must mention our deep sense of gratitude to the chairperson of today's session of URSAE 2022, Senior Professor Champa Navaratna from Department of Agricultural Engineering, for chairing the session successfully. We convey our most sincere thanks to Senior Professor G.Y. Jayasinghe, Head, Department of Agricultural Engineering, for his immense support and willingness to work beyond comfort zone to accomplish our goals. Next, we would like to thank all the department staff members. I'm really falling short of words for their involvement and their dedication to yield the best outcome. Also, our sincere thanks to all the fresh graduates for making this session highly interesting with their informative presentations. Further extending our regards to all the participants for actively joining to grace this event. Last but not least, thank you all for supporting us indirectly and indirectly in several ways to make this event a resounding success. Ladies and gentlemen, we have come to the end of the second session of URSAE 2022. The session will conclude with a national anthem. Please stay silent and pay respect to our national anthem. Thank you very much for joining us today. The last session of URSAE 2022 is on Innovative Technologies in Agricultural Engineering will be held tomorrow. And the event is to be graced with the presence of keynote speaker, Professor Kuroki Sensei from University of Kobe, Japan. Have a great day. Good night.